Hey, everybody, and we are live for our first ever Free Support Friday. Now, for any of you that don't know, this Free Support Friday is actually brought to you guys by anybody that currently has a support package by myself. Excuse me real quick, I got a little bit of an echo in the background. There we go. And with that, I have a ton of customers that purchase support packages through us, have bought training, have purchased Autodesk Fusion's rack in all ways, shapes, or form to help support this channel and support jitcadcam, which is allowing us to bring you content like this on Fridays. And again, this is an open mic kind of session. Anything that you may or may not have going on, let me go ahead and get my OBS pulled back up so I can see what's going on in the chat. But if you have any questions about Fusion, anything in particular that you would like to see, I do have a Discord. I also have a support email down below that will automatically generate a ticket, and that ticket will be sent to me to be able to review and bring it up live on stream. So again, anybody looking to reach out, anybody has any questions about Fusion, wants to see different things, maybe it's minor post-processor edit, going in, machine sim, certain tool paths of that such, you guys have that ability to do so both in the chat window here in the live stream, as well as emailing me directly. And with that, you also have the ability to go onto the Discord channel where I currently am as well and message me directly. Great to see you out there, Hybrid Machining, once again. I know it's you, Jeff. I don't know if you wanted me to say your name, but now that you've put yourself out there, but thank you very much for the videos. Obviously, I'm super excited to bring them to you guys. I also absolutely love to get the puzzling questions, as we just went over an hour earlier, that Wes reached out to me about this new avoid touch machining. So outside of that, it looks like we don't have really anybody in here, which I was kind of expecting that. So I think what I'm going to do, I'm debating on if I want to program up some parts or if I may just go away for a little bit and come back and check. But I do see 2 viewers currently in here. If you guys have any questions, feel free to reach out and let me know. I mean, technically, in the meantime, you know what I am going to do is we did have somebody this week reach out and utilize the buy me a beer, which this isn't a beer. I can't drink a beer live on cam, but it is an energy drink. So why not thank Tony for this lovely energy drink that he went ahead and donated to bring up some of this good content. Awesome. So actually, we did just get our first question from Jeff nonetheless, is what would be a good way to show and add machines to your setups? No, I mean, I get that question a ton. So let's go ahead and do that. Let's go ahead and populate a part. Again, the part really doesn't matter for a lot of this. I do have some jigs and fixture work as well that we could do. Just so happens that I have this one right in front of us. So if I needed to place this onto a actual machine, and now this is a good workflow, it's kind of a newer workflow, is I do, when creating a setup, I highly recommend selecting a machine. Now, you don't need, as you can see in front of me, a super crazy fancy machine by any means. Even something as simple as like the generic Autodesk machine and a couple of adjusted parameters in the kinematics to make it your machine will go tenfold. But I, in this case, have this lovely Akuma M560 right here in front of me. And as you're seeing, this is actually located on a different team. So this is why we do this stuff live, because I encounter problems like this all the time. This is actually one of my customers' machines that we custom built for him. So let's go back. Let's see what we have. We actually have a Fadal machine in here, which is always a good thing for a conversation. So let's go ahead and grab our Fadal machine. Now, once that machine is built, usually that's the pain in the ass part, is building the actual machine itself. And if you guys want, you're welcome to reach out to me to build these machines. But now that we have our machine in here, all we have to do is actually just place our part wherever we plan to actually machine it. Now, as you can see, I didn't bring in a vise or a fixture. I'll go ahead and place a different part in the same scenario, but it is as easy as getting your machine in and then placing your part according to that machine. Now, what I recommend to most people is we set up your machine. As you can see, this just has a lovely joint origin dead center of the table, and you'll see where that's valuable here in a minute. But if I was to go in now, traditional workflow, I'm going to throw a couple tool paths at this. Let's get a lovely 2-inch face mill. And then from that face mill, I can go ahead and simulate this actual on the machine. And now, as you can see, because of all the latest add-ons of the verification is complete, which means we don't have any issues right here in real time. And we can run that machine sim as if it sits inside of our machine. Now, if you were to do something a little more fancy than that, And I assume this is where good old Jeff is talking, because I actually got to meet Jeff in person in Michigan. He's got a little brother Speedio, which is a great machine, but it's still, the rules kind of abide the same way, right? So I have my part, I have my jig and fixture. Now I can set a fixture attachment point here if I want. And again, this is where it's very important to prep your model with joint origins on a lot of this stuff, because it's a hard marker, right? So there's my joint origin. Now from here, I'm going to go ahead and grab that same exact machine. And as you're going to see, is that's going to, again, come in directly on that origin to start. Or if I wanted to, I could actually pick a different point. So now this is something I think some people overlook, is if my machine sim had multiple joint origins on it, maybe I have a rotary, maybe I also have a table location, I could actually define a point basically anywhere I want. So one neat thing is you could, if you really knew it, and from the home position of the machine, even as funny as it is, you could bring that part down and place it in the world of the machine or from the machine home location to be able to utilize that, right? So as you can see, my part is now over here to the left. I think we are multi-axis toolpath, not a big deal. We'll just go ahead and steal our facing from the other part. I'm going to paste that in there. And again, we can now regenerate and right back to the same as be able to simulate with machine. Now, recently, I remembered something that has changed my workflow, which is a great talking point to throw in here. This is a tip and trick that I think a lot of us forget. You hit S on your keyboard, you can create a custom shortcut menu, to which this one has been absolutely eaten away from me as I remembered this on Wednesday's video, is if you're going to be doing simulate with machine a lot, you could add that to that menu. And now anytime you want to simulate something, as you can see, I can hit S. Oh, I forgot to pin it. So we're going to say simulate with machine, and then I'm actually going to click that little arrow over there on the right. But now I can very quickly get to this menu based on the icons and jump straight into machine sim. I could run my machine sim again. Verification should check good as long as you're programming everything correct. And then to up the ante, I'm going to go ahead and throw post-process on here as well. And just like that, now a little more real-world scenario is, boom, we hit that machine sim, we're done. I hit S again, and I can go to my post-process and dump this out and post it. So, Jeff, I hope that helps you out a pretty good amount. Again, I'm seeing more people get in here. If anybody has any questions or anything they would like to experience or see inside of Fusion, please let me know. In the meantime, I think I am going to jump back and play a little bit more with multi-axis finishing on a part like such. So again, we have our setup. I'm going to go ahead and swap out. We do have that stock, which we actually cheated on this part. We said the model was the stock when we initially did it. And the idea was as we did that so that we wouldn't have any collisions with our toolpath. So from here, I would, and this is, again, a big debate I see out of a lot of people. Some people like to use 2D toolpaths. I always tell people, if you're roughing, let's just go straight for the 3D toolpath, right? I'm going to go ahead and grab 3D pocket clearing. Might do something like this with I can't remember how big this part is. So this is going to be interesting. 1/2 inch with a bowl. Grab our splotting speeds and feeds. Because we are doing pocket clearing, this was actually a question I got early. Now, with that, I have that ability to actually do a very large step over. So if I kick on manual step over, I could set a maximum step over. So maybe it's something like 450 and then a minimum of 045. This is missed by a lot of people as well. And then we could actually do our maximum roughing step down. I'm going to actually go with like a 075 step down. Again, if you guys do remember, we now have stock to leave here, but we also have the ability to control our stock to leave and avoid touch machine surfaces. Seeing how this is the first toolpath I'm throwing at the part, I'm going to get a result, which I'm going to show you guys how to change this here, unless I get any more questions in the chat. Seems like there's 4 or 5 of you out there hanging out and probably just watching me program parts. I don't know if you guys just like me, or if you're wanting some advice, feel free to throw that up in chat at any time. I will, before we go a little deeper, let me get my desk pulled up. There we go. I don't see any support tickets come in either. So here we go. We're going to go ahead and adjust this pocket path. again, we have our bounding box, which is actually limiting our toolpath with the center. Now, again, still a little traditional. We could still pull that from setup stock move. And we're going to go ahead and set that boundary to none. And what that is going to allow our toolpath to do, if I'm correct, maybe I'll crash the software again, is now I'm working from the outside of the part in where I can, and then helical boring down. So it looks like we got another question coming in from Jeff. All right, if no one else has questions, I'm pretty sure somebody will pop some more questions in here other than you, is how to turn off a default setting on a post processor. For example, RoboDrill comes with preload tool selected as default, but you don't want that. Well, so there's a couple ways to do it, right? So if I actually go in and I post process this, what I'm going to do is I am going to turn this off for this example. And then I am going to grab just about any post. It really won't matter. I'm going to grab the Fidel post will work. And with that, if there is a setting that you don't want on by default, you have the ability to uncheck that. Now, what you're going to notice is it's going to turn blue. However, the next time this post updates, if it's a non-standard post, it will actually by default change itself back. Now, if you don't want it to show up blue or you want to make a change on your end so that it actually defaults to either checked or unchecked, is what I'm going to do is I'm going to click this little pencil here, which is going to pop open my editor, which is Visual Studio Code. And then in the case of Jeff's situation, he would say, you know, the preload tools function, I'm going to use G8, right? So this is where I can Control F. I'm going to type in use G. And as you're seeing here, we have use G8, right? And now I can go in and I can change that false to a true. And I'm going to go ahead and save this. Now, you could use the hotkey Control S, of course, but I'm just going to click Save. And then we're going to close this out, allowing us to go back in. Again, wait, I should do this. I got to build these new muscle habits, right? So we're going to go at S, post process. We're going to swap out back to that Fidel post. And now, as you can see, the use G8 function is checked here at the top level. Now, if I uncheck it, it would turn blue as such. Jeff, does that kind of answer your question? I'll give you a moment to answer me while I get back to programming this part, hanging out for somebody else to ask something. Feel free to ask as many questions as you want. So as you guys can see, we roughed out this part. A couple of neat features I think some people forget about here in Fusion is you have the ability to turn off toolpaths as well as turn on and turn off your stock. So when I'm reviewing a part, you can see if I click my part, it's giving me my toolpath preview. Now, I'm going to hit F7 on my keyboard, which actually allows me to toggle that stock out of my way and see what is that stock going to look like from what we have defined in that toolpath, right? Again, you can see we've roughed this out quite well based on those settings. I may go back and start to change those settings. I'm actually going to change gears, and let's go ahead and throw at this maybe some, I think we were talking about it. Let's see what we can come up with this new. Where is it here? Actually, it's under multi-axis, right? So I'm going to go in and let's check out this new multi-axis finishing strategy. Now, with this strategy, I've done some videos on it. As you guys have seen, is you can actually use non-standard tooling. And I say non-standard tooling because Fusion now has a new set of tooling. And again, you get this lovely warning, is different cutters based off what you're doing inside of Fusion. And these are all circle segment cutters. Whether it be a barrel, oval, taper, as well as a lens cutter, each one has its place and its use inside the software, right? So in this case, I have a lens cutter. Now that is designed more for the floors of a part, which is actually an advantage to me. I always, if you guys know, like to finish my floor before I finish my wall. So I'm going to go ahead and keep this tool. And what I'm going to do now, and again, this is where this all becomes more and more powerful, which almost starts to double dip a little bit. But I want to do the floor of this part. Now, what I would like to also do is possibly avoid certain areas. And what you're seeing down here at the bottom, it's kind of funny, is because if I actually was to close these two tabs, I have that ability to also generate different groups down here as well. So if I wanted to add my walls in up here at the top, let's go ahead and grab all those walls. One of these days, I'll learn my lesson and selection set everything. And then from there, you can now see we have model, floor, and walls, right? So now I can set a clearance on those walls, which is very handy. Again, that could be, you know, whatever your plan is to stay away from the walls. I'm going to punch in 100 to start with. And then I am going to jump over into my passes tab. Looks like we're doing a 200 step over. That's plenty. We're also doing a lot of things with tool axis tilting because this is a 5-axis toolpath. And I'm going to let that calculate and sit. And of course, like always, why not get problems first time through, right? So our problem seems to be is step over is too big for the specific barrel profile and length. Easy enough. Let's go back and change our step over, right? So let's drop it by half and see what we get. Hopefully not another error. While that calculates, I'm going to go ahead and snag a drink of my energy drink. Celsius, if you're out there and want to sponsor my channel, feel free to reach out. Now, as that calculates, you can see it's taken a little bit of time. It's gone ahead and did the calculation. And a lot of you are probably curious as to why we don't have a toolpath. Well, that's because yours truly over here went ahead and hit F7 earlier, which turned off that toolpath. Now, as you can see, we are going around and we are machining those floors and we are staying considerably a 100 thou distance away from our walls, right? So even though there is that little fillet, we never define that fillet as something to stay away from or to machine. And what I'm going to do is I'm going to duplicate this toolpath. And let's go back and we're going to add into the walls here. And then we can do a side-by-side comparison, right? So get all these surfaces selected. I think some of you are starting to realize now, why did I pick such an L-shaped pocket with so few of surfaces? Makes my life a little easier when I go in to have to show things like this. So again, there's our toolpath. As you can see, our first toolpath versus our second toolpath. We're actually getting one additional path here, which is a little closer to that wall, where, again, based on our avoidance and our model awareness, we're pushing that toolpath further and further away. Now that we've done the floors on this part, I'm going to go ahead and hit this again with another multi-axis finishing. This time, we're going to swap out our tool, and let's just build a tool from scratch. Now, I don't have specs to a tool in front of me, so bear with me. So we actually might not do the barrel. Let's see what else we got here. Let's go in and, so that was oval, table. There we go. There's the barrel. Again, we have our cutter. This is kind of a lollipop profile at the moment. We can also change things out. So this is our profile radius in itself. We go up to 1 inch. What you see now is instead of being more of a lollipop, we've transformed that into a barrel, right? So if I wanted to use this tool, I can stay a little bit more vertical with a little bit of tilting. Again, we have our geometry to define. Where is my floors? Where are my walls? Again, not to say it for what it's worth, as we've talked about once before, is I would be much wiser to do selection sets here, but I haven't learned my lesson. We're going to swap out to the walls, and then I do have the ability to either do a scallop or a blend. Now, again, both have their place. We're also going to guide curve from the floor up, or we could go from the ceiling down, as you're seeing here in our symbols. Step down of, let's go 0.1. I think that's going to be a little cleaner and give us a little bit more. And we're going to do 100 thou, or actually 100 thou step downs and both ways. So again, we could let this calculate out. Seeing more people pop in here to view me program this part. If you guys have questions at any time, feel free to reach out. You could do so by putting a message in chat. You can also reach out to me on Discord, and you can even submit a ticket based on my, let me think about it here real quick, my support system. Sorry, I had a brain fart there. It's down at the bottom. As you guys can see in the link, you have the Discord channel, as well as you guys have that support email address to submit a ticket to, and that ticket will come through as well. So we got our tool path. We're using our barrel cutter. Now, I am using a lot of the default settings here inside of Fusion. I will also take the blame for the fact that neither one of these tools have tool holders. So we may have to go back and change those, but let's go ahead and simulate these here. So as we pull up our machine, what we are going to do is probably get a warning, and that warning is going to tell us nothing more than, guess what? We're slamming into different areas of this part. I'm also surprised we're not getting a warning that this isn't a multi-axis machine. So with that, we may need to go back and swap out our machine. So again, I'm going to go ahead and just get rid of my machine in this case. so that we can see these tool paths go in and do what they need to do. And we're going to go ahead and simulate with machine still. It doesn't matter. You could actually simulate just the part, or we could simulate with machine. At this point, it won't make a difference. So we do have one error. It looks like our stock and holder, again, we're getting so deep into our part, we're automatically hitting our tool against our part. And we can actually automatically calculate that distance. And how you do so is you go into your tool, you go down here to shaft and holder on that tool path. What we're going to do is we're going to detect tool length, and then we can give the holder a clearance. So I'm going to give it 100 thou. And as you're going to see is this is going to update real quick. And now you're going to see that tool automatically just pulled out there in real time. I get a lovely little warning message telling me to, hey, make sure at your machine you pull that tool out by 1.7, that you don't cause any problems. If I regenerate this again, this error is going to go away. So we're just going to leave it for right now. And again, let's go ahead and simulate with machine. So we'll give this a second to think about itself. It says verification, no issues found. We're going to go ahead and run that actual tool path. As you guys are seeing, we're going to machine back that part. I can take my stock and change it to solid colors. And I'm going to speed this up a little bit so that we can get to the end of this actual 3D tool path. Seeing a few more people come in here right now, guys. If you have any questions about Fusion, any problems that you're having in your workflow, feel free to go ahead and let me know in chat. Feel free to send me an email. I'm here to help you guys in any way I can. So again, because we have both ways, what you're seeing is this works around one way, then comes back the other way. We could have set it to one way only versus both ways. But in a nutshell, that's finishing out the bottom of our pocket. Again, we have that one additional path because I ended up deleting the second tool path we made with our avoidance. Again, finishing out that kind of strange curved surface down here. And then we will be switching over to, again, another multi-axis finish with our barrel cutter to be able to go in and approach our walls. And now you're seeing that barrel cutter come around our part. And now all this multi-axis on this barrel cutter is actually auto being calculated based on the position of our tool. And that's for the floors as well as the walls. So what I'm going to go ahead and do is I'm going to make a couple of adjustments to that to show you guys how that works. I just wanted to give you a little bit of an idea of how that's going to go around our part. So let's go ahead and exit that simulation. We're going to go ahead and edit our tool path. And this is the barrel cutter. It's not the lens cutter. But as you can see here, we have the ability to jump all the way over. And we can set our contact tool location, if I can remember where to find it. Of course, it's in the multi-axis area. So we can actually do a lead and contact point. Now, this is where, you guys know why I'm backwards? I hope some of you out there are laughing. I'm backwards because they moved my multi-axis tab, which at first, and I'm still struggling with, I actually do like it much more up here at the front. But as you can see, is I can set the percentage of where that tool is going to make contact, right? So again, that preferred height is to be at 50% of that actual flute length that we have on that tool, right? So again, as that tool changes, I can increase and decrease and everything that is needed to get that tool further down based on clearances, right? So again, we're going to go ahead and hit cancel here. And let's go back and let's look at a little bit more of how we can clean up this pocket. So we do have these lovely little fillets down at the bottom. Now, there has been a couple of different ways we could actually go around those corners. And one of them is specifically the tool path called corner, right? So with corner, again, this is a multi-axis tool path. So we're going to go ahead and say this is a 5-axis situation. We're going to stay vertical until it needs to tilt. My geometry, we have the ability to do reference tool for rest machining. Now, this is where it's going to get a little tricky because this is wanting to look for a tool that you've previously used. And if I go in and I try to pick something like a circle segment barrel, I'm curious what Fusion is going to do with this. So, as you guys know, we can always cause more problems, more harm than good, and we're going to test this in real time. Now, I do need to give this a machining boundary. So I'm going to go in and I'm going to say selection. And let's just go for this first fillet here around the bottom. again, we have tool center on boundary, contact point boundary. I'm going to go ahead and hit OK. And what it's going to want is a tool to go down there and do it. So let's give this a ball end mill. Now, I am going to need to make a quick adjustment to this tool. And what we're going to do is we are going to stick this tool out quite a bit, because I'm more curious about getting a path than I am concerned about using the perfect tool up front here. So again, we go through our process, we hit OK, and let's see what we're going to get. So we got almost nothing, which is better than having absolutely nothing. However, we now need to go back and possibly make a couple adjustments. And some of those adjustments, I think, in the first place are going to be, I think I'm going to actually, can we remove the rest machining tool? We cannot, but we can enlarge said tool. So let's give it, an enlargement of 200 and see what happens. So commonly this corner toolpath is more aimed at the fact that if we did like a contour down these walls and then we were going back and blending. Now, again, what is happening, and I believe this is because the tool we defined more than anything, is we're still staying in those 4 locations. And we're now working our way from the top down, where, again, the corner toolpath is trying to recognize that 3/4 circle segment barrel, which isn't an ideal tool for what we're doing. So let's swap some things out here. So let's go back. Let's go for a 1/2 inch ball end mill. And then what I'm going to do is I'm going to swap out the 1/2 inch that I selected for this machining process. And I'm going to grab a 1/4 inch ball end mill. And then we are going to have to modify once again that tool, because we need that tool to stay away from everything going on. So for most of you, you probably already have everything set up at this point. So we're going to say overall length. Again, we got 2.5. Length below holder, we'll go ahead and stick it out that same distance. And with that, we're going to see what we get for a toolpath. We should see a much better blend around that bottom radius. But as always, I'm curious to see what I get. This is why we do a little bit of trial and error inside of Fusion. So we did get a lot more of a toolpath. We're not all the way around yet. So that would lead me to believe that either there's a problem with my boundaries that I've selected, or we need additional offset, because I have a feeling the guy who designed this, yours truly, probably put a 1/4 inch radius down there in the first place and is causing all these problems, right? So let's go ahead and give this an additional offset and see if we can't fake it a little bit to get a little better toolpath on the part. Again, seeing more and more people jump in here. If you guys have any questions at any time, feel free to throw them up in the chat. Feel free to message me via the email down below. Reminds me, I should probably go check, see if there is anything in the support email. Now, I don't see anything yet. We're also in Discord right now as well. If you guys want to join our Discord channel, we've set that up to be able to make it a little more easier on you guys to get access to us, as well as you can, instead of installing brand new apps, I hate installing apps on my phone. Discord is something I use all the time for playing games. So I figured you guys would like the Discord channel. So looks like Travis is asking for it. Let me see if I can pull it up here real quick while I'm live and stick it in chat. But it should be down in the description of this live feed. So right here is got it here. Let me get back now and I can post it in here. So that should be the link to the Discord channel. I believe somebody's already used it a couple of days ago and they jumped in. We're at a whopping 2 members in our Discord right now. So hopefully that grows here over a little bit of time. So again, let's go ahead and see what is going on with this toolpath and why can't we get it to work? Well, as I tell you guys all the time, y'all are going to put in a support ticket to me. You're going to say, hey, I can't get this thing to work right. Now, what I'm going to do is I'm going to do what I always do, right? I see what you're trying to do, and I'm going to delete that toolpath. And then I'm going to go back, and I'm going to grab the corner path tool again. And then I'm going to give it a lot less information, because I think I broke my own rules here, right? So we have our lovely 1/4 inch ball end mill is the tool we're going to use. Our geometry is going to be based off of that reference tool of a 1/2 inch ball. And then we're going to just do the plain old thing called hitting OK. So I did just see somebody jumped in. Looks like we have another person inside of our Discord. Awesome. We're up to a whopping 3. But now we let the thing do its job. We're going to let it work. I'm just curious what my tolerance is on this toolpath as to why it's taken so long. As always, here's a quick tip for you guys. We're going to go ahead and drop that 4/10 to 4 thou. This will allow us to calculate that toolpath much faster. Again, with this channel, we're all about trying to give you guys different workflows and different ideas. If any of you are suffering from some real world scenarios today, feel free to reach out, as I would be happy to go in and help you in any way I can. So as you can see, it has now recognized, based on that ball end mill versus what we have set inside of here, is, again, the biggest thing that you could do is give it the least amount of information to get the outcome that you're looking for. And what that has caused is us to get that lovely little fillet around the bottom of our part. So now we can increase it a little bit if we needed to. In this case, I'm going to go ahead and say, what if we enlarge that tool by 0.1? I love this feature in Fusion, guys. You guys have already probably all known about it. So we can actually go in and ignore regions. We could go in, and anytime I put my tool anywhere I have a question, we can increase and decrease or get a brief explanation of what's going to happen. What should happen is, by enlarging that tool by 100 thou, and I'm going to figure out whether or not that's diameter or radius, we should now see that fillet toolpath reach much higher up off the wall. So awesome to see all 7 of you in here. We're growing pretty quick. This is pretty good to see. We are seeing that that toolpath is now actually spread out both on the walls and on the floors. Again, allowing us to blend that bottom fillet between the walls and the floor. Now, again, we have a lot of things we could do to this part. We've failed to do the upper portion. So what I'm going to do is I'm going to go back to that lens cutter in this case. I'm going to copy that toolpath. Actually, I could Control D and duplicate that toolpath. And right after we did it up here at the top, no reason to do a tool change, but let's go ahead and swap out what we want to do, right? So I'm going to unselect everything. I'm going to go ahead and grab this surface as my floors, and we're going to hit OK once again to see if we get the same outcome. So we indeed did get an outcome. It may not be a perfect outcome, but we did get an outcome. And what that outcome is what I'm seeing, and the way it looks this toolpath is going is it's actually using the outer boundary to create my offset passes towards the center. So I'm going to go ahead and pause there, though, before I show you how to fix this or how we could change it, because I see another question came in. So ball mill radius is the same as the floor fillet. Can you do a single trace on the floor fillet? Yes, you can. I'll show you that here in a minute. I just wanted to acknowledge that I do see you there in chat. So let's go ahead and fix this guy real quick. And this is, again, one of my favorite things getting into this multi-axis finish. We do have that ability to set our floor surface. We have our wall surfaces as well, as you guys are familiar with now. We also have to offset pass using. Now, this is a cool thing where we can actually say, based on said curve, I'm going to pick this one curve, and I'm going to hit OK. And what you're going to see is this is going to more or less kind of morph that multi-axis finish now more into a parallel toolpath, right? Because I'm using that straight edge. That edge could come from a sketch if you guys wanted, or it can come from your model as you see me do here. I'm going to go in and I'm going to go ahead and change that edge selection out again. And what I'm going to do is I'm going to grab this 3 little edges around the inside here and hit OK. And what you're going to see is this is now going to wrap around following those guide curves. Now, again, where that guide curve stops is the reason why that is now looping back around at both ends. But as you're seeing, it is now projecting the path outwards from those guide curves. So, Jacob, I see your question there. It looks like you guys support 3-channel machines. Currently at this time, unless I stand corrected, Fusion does not support multi-axis machines right out of the box. However, I do have customers that are using Fusion to create what I would say is the meat and potatoes of the actual G code, and then they're posting it together and they're stitching it together on their end. Now, if you were looking for a solution that does support 3-channel, we also sell and support Feature Cam as well as Part Maker, which are Autodesk products. Now, getting back to that mill radius or the ball radius going around the bottom edge of the part, let me go ahead and inspect this real quick so it doesn't make me a liar. Yep, yours truly designed a terrible part and used the exact same fillet on the floors here as the tool itself. Now, if I wanted to, could I do a trace? Yes, you could do exactly like you said. Is a trace toolpath is going to actually follow the curve you selected, So it, in this case, will vary in Z as it follows that line. So if I go ahead and say trace, I pick this bottom edge as easy as can be. And just like that, I've now come down and I've traced right around that part, keeping that tool perfectly on center. Now, depending on how you've machined this part, of course, you may need to be a little self-conscious about what happens with your blends here in the corner. So, do I have any other questions before I jump on to deburring this part? I'm going to go ahead and give you guys a couple moments to answer. No, we do not sell solid cam. So we do not sell solid cam. I've seen solid cam. I mean, it seems like they're doing great things. I do know, like you said, it's also based inside of SolidWorks by all means. We also offer HSM Works that goes inside of SolidWorks, but it's not going to get you any closer to that multi-channel situation. Now, getting back to our part here, let's go ahead and throw some deburring at this because, you know, in this case, we don't want to go ahead and cut our fingers on anything. I'm going to pause before we do deburr because I just saw another question come in. How can I model a vise on the B90 saddle of my UMC? Ken, I love that question. And what's funny is I have a video of that actually on my YouTube channel. So if you haven't done so, I highly recommend you subscribe to this channel. But if you go ahead and click that little jitcadcam at the bottom of the corner, you can find the video. It was one of my earlier videos where I put a vise literally on the side of a UMC 750 so that you can use that for all of your first setups or even your second setups, right? So let's get back in here. Let's get this deburr going. Travis, I did see your message pop up. I'll go over that here in a moment. But we're going to go back to our 3D and we're going to come down to deburr. Now, for some of you, you guys are probably seeing what looks like a lovely little extension cord plugin on some of these toolpaths. And I want you guys to know is that is the machining extension, or what they have rebranded as the manufacturing extension, because it now comes with nesting and some other goodies. But you can add that onto your Fusion at any time throughout the year if you purchased your Fusion through a reseller like myself. The value of that is let's say you bought Fusion and you started to learn over the first 6 months. Then the last 6 months you want to add that machining extension, we can add it onto your contract and prorate you for that. Now, as you can see, I'm going to pull out the deburr toolpath, and this time I'm not going to be a fool. I'm not going to go click a bunch of buttons because it's got me in trouble already today. Let's go ahead and hit OK and see what we get. This tends to be definitely one of my more favorite add-ins to Fusion, and for many years, if you guys knew me, I used to say they should relabel, where is it here, the 2D chamfer to deburr, but I'm glad they didn't. Because with the new deburr toolpath, new-ish deburr, you can now see how we can go in and actually find all of our edges, including our vertical edges here, which I'm going to show you how to avoid those, and automatically find even something with some crazy surfacing, as you're seeing with the surfaces on my part here. So again, as if I didn't want to do my vertical walls, I have the ability to go in my geometry tab. Now I have what's called edges to exclude. So I could go through, and you're going to see me pick all 4 corners here. And then I can hit OK. And now you're going to see that we're going to deburr everything except those actual 4 vertical corners. Now, you get to play devil's advocate, right? Like, are you better for saying what not to do, or are you better for saying what to do? Because this toolpath works both ways, where I could actually say, instead of edges to deburr automatic, I only want to deburr. And now you're going to notice this changes to selection, these 2 inner profiles. And now what you notice is I'm only deburring where I've selected those edges. Yes, Travis, it is worth it in my opinion. Even going back to the days of like a simpler 3-axis machine, the machining extension has things outside of just deburr. I think deburr is worth it, right? But the toolpath trimming has always been one of my favorite things for avoiding clamps. I mean, on a part like this, if I had a big old chunky clamp because we bolted it down to the table, you could come in and say, hey, watch out, there's a clamp over here, and maybe there's a clamp over here, right? Now, I'm doing this in a 2D view, so anything within this view in this direction is going to be trimmed. But this is where everything changes, right? We know about toolpath containment. We've used sketches for containing, staying in, staying outside of. Well, have you ever seen a toolpath be able to do both, right? So I can actually say both here. And what this is now going to do is split my toolpath as if I was going to move my clamps after the first part, right? So this is, again, to me, toolpath trimming is insane. It's super neat if you have to deal with clamps or things in your way, or you only want to machine like one area of a part. You have that ability inside of Fusion. With that, it looks like we got another question. Does Fusion have a way to force moving the Z-axis to max height after every tool change? Will this take a modification in the post? Well, Ken, overall, so you want to move up to what I assume, so you have tool change position and then you have machine home position. And both of those are controllable at the end of the day. If you're using a Haas machine, there's actually settings in your controller to manipulate that. But if I was to go in and post out, and I'm just using Haas as an example, no favoritisms here, right? You do have that ability to set a safe retract in this case to whatever you need it to be. And now you could go G53 and then you could comp that G53. Now we can manipulate a post if it does not currently support that to do that as well, where we can force, go up to tool change or go up all the way to machine home change, which would be nothing more than a 53. And this would be a relatively easy change. And if you guys want to see it, let me know in the chat. As you're going to see here, is we're starting off G53, G0, Z0. I could say, actually, I want this to be output as Z4, right? So I'm going to give you guys a couple of minutes because I just have a hunch that somebody's going to say, can you show me how to change that in chat, right? In the meantime, let's go ahead and make sure there's nothing crazy going on. It looks like one of my customers texted me here, of course. Yep. So, I mean, I could literally set it to that. I don't think I can actually highlight that, but so if I wanted to change the post, I could change the post to put exactly that, right? So 3.38 inches above the tool change height. And if you wanted to see how that would be changed, again, if I go to post process, as you're seeing, I have that same exact post populate. I'm going to hit edit. Make sure you have the Fusion plugin installed, right? Because what this does is it color codes everything so nice. Get this closed out here. But what it also allows you to do is to cheat, right? So now I can come in and I can say, let's go ahead and do a milling 2D. And in this case, I want to do a face. It's going to spit out this lovely debug file. If I click that Z0, as you can see, it's going to write retract Z. I can change this out to write a Z plus whatever. And I could set that as well. So again, is depending on what you have going on, you have your G53, you have your Z heights. You could change out your right retract Z as well. We could change this instead of right retract. We could say, if we were going to hard code this, right block. And then we are going to put, oh, let me back that up. All right. So we want G53, G0. And then we want, what was it? Z3. We go back over to chat, 3.8. And then we're going to go ahead and hit save. And as you can see, it now has populated this up here at the top. So I may need to repeat that exact same move here down below. Now, what I would recommend is if you are going to change your post, I'm going to undo this because I've already copied it, is to not actually change what's right here. Is I would actually double backslash this. And then the line right below it is where I would put in what I wanted. And the reason for that is because if I ever have to go back and undo this or fix it, I can do that in real time, right? So again, I'm going to go down here to the bottom. We're going to go ahead and say double backslash, next line. And then just the same way as we did before, hit save. And now you can see, in this case, we've actually crashed our post processor, causing all kinds of problems, right? So it's not possible, and this is a safety precaution inside of Fusion. You cannot retract, or retracting in XY is not possible without retracting it in Z. So this will take a little bit more work to straighten out, of course. But as you can see, it is possible to change and get that back to whatever you need it to do without causing severe collisions. And if you cause severe crashes, as you're seeing, this is why you can reach out to me, and I could spend probably way too many hours editing and changing something like that. So as I'm seeing, is I think another question has just come in. Options for M06 pick of M66 pick. Custom safe tool change locations set up on my machine for long tools. So this would be something that we could add in. You could make everything M66 or M06. And there is going to be a little bit more to this than I'm probably going to be able to do in this meeting by any means. But what you would do is at your tool level. So there's a couple of ways I've done this before, right? So let me get back here. So if we edit tool, give it a second here. You do have the ability in this case is maybe you're not using manual tool change and we use this checkbox to trigger M66. Another way to do this again is we can actually do what's called a manual NC add an action. And what that could be is, you know, something like long tool. Now your post isn't going to support that by default. But the nice thing is again, Fusion is open, as you guys have seen in some of my other videos, the tricks of the trade, the debugger, like all of this stuff to go in. And now with that, we're going to go ahead and go all the way up to the top. This post in itself already has manual NC action commands. So we may need to add in our own command. And again, this is something you guys have the ability to do, which is why I kind of want to give you guys the answers to the test. But if we control F, that actual NC action, you'll see there's is string, here's manual NC command, so forth and so on, right? So now you guys can chase down what it is that is going to do this, what it is that's going to do that, and how you can actually put that in there. In the meantime, do I have any other questions, or you guys want to see me do a mill term part? Might give it a couple of minutes. Let's go ahead and check a few things real quick. So it looks like I did get an email in. Let me go ahead and make sure that isn't from somebody that wants their parts put out to the world. And let's see here. So I believe this is one of my customers, so I can't actually share this toolpath unless he would like me to. So I'm going to go ahead and skip that one for now and email him back. I'm not seeing anybody saying that they want to see a mill turn. Do you guys want to see more milling? What do you want? Can you add a tool description as a tool list on the post? Yes, you can. Most tools, or actually most post processors already support that. So what you would need to do is you would need to turn on the right tools list right here, if your post has it. And what that would do upon posting, and I'm going to post this out so you guys can see it, because it helps if I click the box to open it up, is this is going to give you this description right here. Now, this description can be changed and edited to be more accommodating to whatever you need. In this case, tool number, diameter of the tool, corner radius, min, maxes, and description. Now, a lot of this information is auto-populated by how you define your tool. So if I go in and I edit tool in this tool 6 situation, we have one description, and then we have all of our cutter specs that are also pulling through as well. Lastly, of course, you have your post process with your tool number, and things come from there. Other questions? No other questions? I see them keep coming in. It almost makes me feel like this might be an every week kind of thing. So getting back to the tool pathing side of things until we see another question come back in. Of course, there's another question. Can you demonstrate multi-axis finishing? So Ken, I think you might have joined a little late. Right at the beginning of this, we actually just rattled through both using a lens cutter as well as a barrel cutter on this part in particular. However, I am more than happy to show more of the multi-axis finishing if other people would like to see that, or if they're curious about something else. So let's see here. We're going to go ahead and pop open our lovely parts here. So it doesn't look like anybody's coming in, Ken. Oh, no, you're good, Ken. We understand. It's all, hey, that's why I'm doing this for a couple of hours. You never know what's going to come through. Because, I mean, we did actually do exactly that on a part like this. Again, this is kind of like a structural gusset part. And again, multi-axis finishing is extremely easy to use, right? So once you define your tool, again, I'm just going to use the circle segment cutter that I have in this tool already. We go to our geometry tab. In this case, we can pick our floors. So if I go through and grab my 3 floors, and easy enough as we've learned, just hit OK, right? So we'll give that a second. In this case, we've crashed it. Step over is too big. Same thing we saw before. We can edit our tool, just so you guys know. The reason where that's coming from is I could actually set a step over for this tool. And now with that setup, I got an earbud connecting and disconnecting. I think my battery's dying. So what I'm going to do is I'm going to go in, and as you're going to see here is we can go ahead and edit that as well here. 0.1. And then what you're going to see is that's going to come in and machine all those floors. So it looks like I got another question from Jose Mendoza. You would like to see a sub-spindle transfer. No problem. I'm happy to go ahead and do that. So let's go grab another part. I think for the lathe parts, I always like to go to the cam samples. To anybody that possibly messages me on Discord, I'm not going to hear you, of course, because I pulled out my earplugs. So give me a minute. So let's go ahead and grab a part. In this case, I'm going to use this live tooling part right here. Looks like my camera just went away for a moment. What is going on here? Give me a sec, guys. I'm going to kick my camera off and restart it here. All right, I think we're back. Am I bugging out a little bit, or are we good? What does my live feed look like, right? That's kind of the question at this point. Am I still smooth on live feed and OBS Studio is freaking out, or what's going on here? The fun of live video, right? The fun of live video, right? The fun of live video, right? Oh, I think I've got audio loop back. There we go. So it looks like I smoothed back out. All right, we're back. Cool. So here I have a part. I'm going to go ahead, and the reason why I like pulling these default parts in for a lot of you guys is so that you can practice this on your own if you're going to pull up this video and see. So again, pretty standard setup here. I'm going to create setup number 1. Again, we're going to be working turning, mill turn, primary spindle, and basically you guys are going to go through and set this up the same as you normally would. We have our stock and even our post-processing. So in this case, I would change to WCS1, just knowing that 54 or work offset 1 is my main. Now, normally we would go through, we would do all of our turning and all of our different tool paths. But what I'm going to do here is we're going to go ahead and start by coming in for our sub-spindle grab, right? And so you guys know, if you want a copy of this, I actually ran through another video on my channel of how to do all of that handoffs and the part grabs and all of that. But let's keep this going for you. So 1, we need to set how far we are grabbing inside of our part. I'm going to go ahead and hit OK here because I don't believe in working in millimeters. So let's go back to inches, right? So let's go back to our sub-spindle grab. And now let's grab based on a pretty easy measurement. So we're going to go ahead and grab minus, let's say, a ½ inch into our part. That might be a little overkill. So I'm going to bring that back. Let's go with minus, actually, let's start a brand new tool path. I think that's going to make life much easier on all of us. Sub-spindle grab, get a little better math this time. There we go. 300 in. I've now grabbed onto my part. So in the case of this, it's going to be a use case for each individual scenario, right? Because I need to decide, is my job going to be to transfer a slug from main to sub? And I say slug because this part would be too big for a through spindle or a bar feed. Do I need to do a bar pull motion and then part this off, getting me set up for my next one? Or is it just a combination of both, right? I'm going to start out with this as if it's just to come in, grab it, and then return. And how I do so is we're going to go follow up the sub-spindle grab with a sub-spindle return. Now, I need to return to, in this case, maybe a machine position. Now, on some machines, and you'll see this in my post, I can actually set a sub-spindle position, right? So now that we've got that, I need to tell the software, hey, unclamp the primary, right? Because I like to think of it like a left hand to a right hand move, right? I'm taking it out of my left, so I need to open my left hand for my right hand to go back, right? So again, we unclamp primary spindle. I'm going to go ahead and hit OK here. And just like that, we've done a spindle transfer, right? It is as easy as that to come in and grab and then return. Now, if you wanted to up the ante here, and Jose, is that what you're talking about? Or do you want to see like a part off as if you're bar feeding and a bar pull? You go ahead and let me know in chat because my voice is starting to get a little hoarse here. In the meantime, I'm going to, of course, check all the different resources as to who, what, and when might need a little help here. And it looks like we don't have any emails coming in yet. And we are closing in on the first hour of this, which is really good. So looks like Jose just wanted to see the transfer. So again, the transfer is very straightforward. A couple of elements and warnings that I give everybody is when you do this is depending on your machine, your B axis is your sub-spindle. So make sure you touch that off as if it's almost a tool in your machine. And then what we're doing is we're doing the math here to determine how far from your work offset are we going to go in and grab for the transfer, right? Once you do the transfer, of course, then you do still need a second setup. That second setup, we're going to swap out to a secondary spindle. And then again, you could now start to machine the backside. Oop, I forgot to flip my Z-axis. And being the person that I am, I personally prefer to use a selected point or model back on my flip because usually I've cut those jaws to fit and grab everything perfect there. So seeing more and more people come in and join us. If anybody has questions at any time, feel free to let me know. I'm happy to help you guys in any way and put this content out there. In the meantime, I guess I should pull up the fact that, you know, good old Autodesk right now has a Fusion promo going live right now. So they are offering 30% off the base license of Fusion. Now, if you're in North America and you would love to work with me over here at jitcadcam, good old Fusion Phil, feel free to email me down below. I'm happy to get a quote over to you. Again, anything that you purchase through us helps support this channel, keeps everything free, keeps the info going for anybody out there in the real world. So getting back into this, does anybody else have any questions? If not, I think I'm going to take a 5 or 10 minute break real quick here because we are at the top of the hour and I still have a few hours left to do this. Again, for anybody that's in here right now, you're more than welcome to hang out until I get back here in a few minutes. Or if you have any questions, go ahead and throw them right inside of the chat. All right. And we are back. Thanks for anybody that's new and joined back in here. I see you guys over there in the chat. Looks like Ken had a question real quick. Obviously, we already answered it. Yes, we will actually, this stream will be available after this. It is recorded. It is published on the channel. We may actually make some edits to it, of course, because we like to break this up into smaller sections, make it a little more palatable for a lot of you out there. And if you are just joining us at this point, if you have any questions by any means, throw those questions in chat. I'm happy to hear it. I did actually reach out to my customer before. They were asking about a certain feature on a part, and I think what you guys are going to get to see me do is I am going to recreate what they kind of have going on, and then you can see how we would approach this. So give me 1 sec here while I figure out the best way to go about this mentally to draw something like this, as well how I cannot give away what they are exactly trying to do. So let's go ahead and grab this, and here we go. So what we're going to do is we're going to go ahead and clean up our workspace here. Odds are I'll be reopening that file up here anytime because somebody's going to have more questions. And I have a couple of spins on this part I think you guys are going to get a pretty good kick out of because there's a few things that might also be needed on a part like this. So what I'm going to do is we're going to start by our lovely design space, and I need to sketch out what they're doing. I'm also a firm believer of any time that you could cheat the system, let's go ahead and cheat the system. And what they are doing is something like so. So let's say this is 2-inch. We need these two horizontal, vertical. Looks like I just got another message in Discord. Let's see what we got going on. Oh, it is one of, if you guys didn't know, yours truly got to go out and host a Too Tall Toby event. And he actually just reached out to me and sent me all of the flyers. I might have to download these and pop them up. They need your guys' help. So what's going on is we actually have a guy, actually 2 guys that are in the finals. Let's see here. How can let's save image. Uh-oh, there we go. Save it there, and then what we're going to do is we're going to pop this open here real quick. And that should be it. Awesome, there we go. So the Too Tall Toby crew, if you guys don't know, I know it's kind of crazy for me to bring this up, but he did just send them over. They do a CAD versus CAD, and I got to tell you, I'm trying to figure out a way to do a CAM versus CAM, but this is some of the craziest things I've seen. I'm trying to get my big old fat head. Maybe I'll move this over for you guys. So this is one of the craziest tournaments I've seen or even got to co-host. And with that is we do have 2 Fusion runners in the semifinals. And I will tell you guys, you want to see some crazy modeling, go check out what these guys are capable of, as well as any of the other CAD softwares. They're great softwares, but of course, my heart's with Autodesk. We lost one of our Autodesk guys last round with the Inventor CAM. He just so close, like down to the wire. These are like perfected workflows nonetheless. Would highly recommend go check out the Too Tall Toby channel. Make sure you subscribe and get notifications. I don't know if they're going to invite me back. They got me 2 weeks in a row for hosting, but we'll see what happens, right? Maybe I'll be the finals host. Who knows? But getting back to this part, as you guys can see, we're going to go ahead and tangent this. I know it's going to be a little tricky because you guys don't know what exactly that customer is going to be doing. We don't want to show off all the meat and potatoes of what's going on. I did send them the link to this live stream, so hopefully they jump in and see this. And what we're going to do is we're going to throw some dimensions on here just to clean this up a little bit. And let's say this is a 375. And then lastly, because I designed that kind of bad, we'll drag that down and get it locked in. So the part they are working on is something about like so. However, it is mirrored. So what we're going to do is we're going to grab that part. We're going to mirror it across the center plane. We're going to join the 2 halves together. And now as some of you are looking at this, what we have is just a concave in the middle with 2 fillets up at the top. Now, if you know how to do a part like this, or you can think of a way to do a part like this, I would love to see you guys throw it up in chat. I'll give you a moment to respond while I go check my lovely Discord notifications. And with that, it's just, yep, okay. So that was one of the people inside of Discord was just messaging me about something else. But with that, I don't see anybody answering in chat. How would you go about, I'm just curious, you have to 3D basically these three surfaces at the top, right? So what the customer is wanting is to use a 3D toolpath. This might also be a little bit too long for their machine, which is going to be the little trick that I'm going to show you with how we can use boundaries and maybe even toolpath trimming. So let's go ahead and get our setup going. So we're going to switch from design to manufacture, and we're going to create our setup. Again, this is going to be for milling. Location of that actual work offset for most of you could be top back, could be top bottom. Again, we're not going to concern ourselves about our WCF location unless that is some of the questions you have. So from here, stock size, good old standard fixed size stock. And I'm going to round up by 0 just to cut down on our toolpath time. Now, I'm going to go in and I'm going to hit this with a 2D pocket clearing, or not 2D, a 3D pocket clearing. And then a good old bowl end mill. And we can let this thing kind of just do what it needs to do without adding a lot more to it and causing problems. Again, because by default, this is a pocket toolpath, it is thinking to stay within that boundary. So we may actually have to go in and say, you know what, in this case, we want to go from setup stock. And we're not quite fully outside of our boundary, and that's because our boundary is still bounding box. So let's get that kicked off. And now, as you can see, we're going to be able to go in and rough out the entire length of this part. And we're going to see what happens because she is struggling and thinking. So while that is going on, I do have the ability to go in and start creating other toolpaths. Now, if you caught some of my content earlier, the joke is, you know, there's some times where you can go in and create scallop toolpaths and they could do wonders for you. In this part here, it may be easiest to start with some of the older, more traditionally known toolpaths before we attack this with any other toolpaths, right? So again, we have our lovely 1/2-inch ball. We are going to be doing everything based on a 20 step over. And what I'm going to do is I'm actually going to give this a selection boundary. And that boundary is going to be around that upper rail, the full length of the part. And we're also going to come back and try something new because I have a hunch I think we can get away with a few things here. So now as that is calculating out also, it looks like we're having some issues with the pocket toolpath. So let's go back. And I know this is kind of a funny thing, but if we switch from none to selection and I hit OK, as you're going to notice, it actually calculated that out extremely fast, right? So by having no selection in the boundary versus none, this has caused this toolpath to actually calculate and spit out what we needed. However, it is not quite outside that boundary. So let's go in there again. We have a machining boundary. We also have our rest machining from stock setup. So this time, let's go ahead and give this an edge selection to machine, right? And see what we get once again. As you're seeing is we're still stuck on the center of that boundary. And the reason for that is because we actually have tool center on boundary. So what I'm going to do is I'm going to say tool outside of boundary. And with that, we should now be starting outside of our boundary. And we're still helicking in. However, we are breaking out the ends of this as we open up that pocket. Again, we could play with this roughing more, but the problem that the customer is having isn't necessarily the roughing. It's getting into how do we actually finish out that concave shape, right? So now I did a scallop, and now I assume some of their problems are going to be is when you get to this end of this scallop, and I hope you guys can see this, those parts kind of finicky and long, but we actually come down to the end of the part, we make a right-hand corner, and then we go back up and around, and we may have some problems with blending down here at the end. Again, we're now up milling with that tool as well as down milling with that ball end mill, which could actually cause a lot of problems on that tool. So there's a couple tricks here. Is one, maybe we don't use scallop, right? So if I go in and I'm going to derive, and what I'm going to do is I'm going to switch out from a scallop into a parallel. Now I am going to add something to this parallel toolpath. And what that is going to be is I want to ensure my direction goes down the length of my part. Again, our step over. Now keep in mind, this is step over versus step down. The same with scallop. Scallop is a step over toolpath. When you get into steep areas, we start to have some problems here on our part, right? So again, I'm going to remind you guys, I see more and more people jumping in and jumping out. I hope it's not the same 6 of you, because odds are you guys probably should just stay in versus leaving. But as you're seeing, you guys can ask questions at any time in chat. I'm here for you guys. I'm here to help out in any way. And you can ask questions as so is you can go ahead and you can message me directly via email down below. There's a support email. It'll create a ticket so that I can get to that. As well, you guys can join our Discord channel and you can send me a message via Discord. So what I'm going to do is I'm going to go ahead and jump back to my email. It looks like the customer actually sent me the model. So I wonder if they're curious if I can use your model. Presumably, if you are out there and you know who I'm talking about, if I can use your model, please shoot me an email real quick and tell me I can. But again, what we have is we're 3Ding down our part. Now, this is something that is very common to happen, right? So as you guys can see here, we're not going all the way over that hump, right? We're not chasing down that surface. So how you can fix that, because we did define a selection boundary, I can actually turn on what's called contact point boundary and then hit OK again. And now, as you can see, I'm getting that entire M profile here. I say M, where my toolpath now has shifted from center line of tool. Awesome, Michael. So it looks like we can use the model. We'll pull it in here in a minute. But as you can see, is now we're no longer constrained of center of the tool touching that radius. We're constrained to center of where that actual tangent on our tool is touching the surface, right? So now we've overflowed on both sides of this, and we have that ability again to run down the length of the part, and with that being able to machine it out. Now, Michael, real quick, have we answered your question yet? Because I'm happy to keep going by any means. Also, what is your question? So you kind of sent me a vague email about doing a screen share with you to help you, but if you want, feel free to throw in chat what is the exact issue you're having, why I continue on here. So again, step over, because this tool path is calculated by step over. I'm going to kick my stock off here. We get to a point where we're so steep that we don't need step over. We need step down to be able to fluctuate in that area, right? And as we saw in the scallop toolpath, we are changing directions right here on the surface of this part. So I don't know the full purpose of this part. If this was a stamping die or something, surface finish means everything, right? So there's a couple ways we could remedy this. And the first way would be is to choose a completely different toolpath like steep and shallow, which is what I'm going to start with, right? So we're going to go ahead and grab our steep and shallow toolpath. Again, we have our machining boundary. We have our part. If I wanted to give this a boundary, again, I'm going to go for selection here. We're going to edit that chain because we want it to run the length of the part. We also want it to start from the edge of these fillets for any containment reasons. And then again, contact point boundary is always our best friend. And we're going to hit OK. So what we're going to get is we're going to get a combination of things here. And we're going to give this a second to calculate because steep and shallow will take a little bit more to calculate. And you'll see why. And it's because it is multiple toolpaths rolled into one, right? So what I'm going to do is, there we go. It actually came through. Now, what you're seeing happen is we're actually getting a scallop in the shallows. So you can see this in 3 different places. I actually really like this part. This part is amazing. Containing the toolpath with the new selection method. Okay, we'll verify that here in a minute. So again, as we're getting the scallop toolpath up here at the top, the bottom, but then we're switching to a contour in the steep areas, right? So what I'm going to do is, again, because we don't want that scallop, surface finish is very important, as you're hearing from Mr. Powell over there, is we're going to swap out that scallop, right? Again, we could go to our heights tab. Guys, this muscle memory is killing me, right? Like, for a lot of you, you're in the same boat as me, where I'm so used to the 4th tab being my passes tab that I end up in the heights tab and I confuse myself. So let's get to our passes tab, the 5th tab. I'm going to take one of my shoes off of my sock here in a minute. And we're going to change our strategy. So initially our path was scallop. Let's go to a parallel. Now we can do a fixed direction and we can select said direction. And for the sake of this show, we're going to go ahead and drop our tolerance down so we get a much faster calculation. Again, we'll jump back here in a second and we'll go ahead and modify what we have going on. But as you guys are seeing now is we're starting our lead in off of our part. Again, this is so great with the old deep and shallow toolpath. We're starting off the part and leading in. But now as you're seeing is all of my toolpaths, let's get these linking moves out of the way. my toolpath is running the length of my part, and I also now have two different controllable surface finishes to happen, right? So I can control my step over separate from my step down. Again, just like most toolpaths inside of Fusion, we have that ability to go in and control a step down versus a step over. Again, fully customizable to be able to change how this surface finish is. So now what I'm going to do is let's go ahead and pop his part in here. So I'm going to get back to a suitable folder where I can hide this stuff. Go ahead and go Fusion Friday. And actually, I don't think I ever set up a support folder. That's all right. We'll get one set up here in a minute. I'm going to get back to his file. In the meantime, hopefully you all are having a good time. Obviously, you're chilling here in my video versus working. So either you guys are in other countries or on third shift. So let's get this model uploaded now. And we're going to go ahead and slide this over. And we're going to see if we can do the same thing with what he has going on there. Is it safe to say, are you running out of travel length on this part also on your machine or not? Oh, I see Ken in the chat. Ken's got one of them gravy jobs. You on some 45-minute cycle times, right? Where you get to twiddle them thumbs, right? So we got our tray pulled up here. Again, we're converting that over, so it's going to take a moment. And as you guys can see, it's kind of funny. It's almost like the same exact thing that I had here. So let's go ahead and pull at a dimension on this to make sure it's not crazy big. Okay, so we got a 1 inch wide. And let's just kind of start this whole thing over again. Oh, man, Ken is just living the dream. 3 hours to program his next part, and then just in case, be there to hit the emergency stop. Man, this guy, I tell you, he'll be the first one to complain, too, that it's a rough life, right? But, okay, so what we're going to do is we're going to go to our manufacturer tab. Again, we're going to create our setup. I'm going to define my Z because my orientation of my model is not the same as my world coordinates position. So let's go ahead and use the bottom since we know it's flat. Again, we could set our x-axis, we could set our y-axis. I'm going to leave it bottom center because it's not going to matter for getting the path on the part. Fixed size box as always. And with that, we can go in and see what we can get for a toolpath. So again, if we're looking at this a couple different ways, we could start with a parallel. We could also actually try to attempt this with a contour toolpath. So if you haven't done so, there's 3D contour, which has some really neat tricks. Now, the avoid machine surface was something that he brought up about being different. So what I'm going to do is I'm going to use the traditional approach, and then let's go ahead and see what we can come up with, right? So traditionally, as I know, we would just say selection. Mr. Powell's going to get mad at me here in a minute when he realizes that it was a misclick more than it was actually a problem. Very common with my customers. He'd probably be the first one to tell you. So we have our chain for containment. Tool center, contact point boundary is now on. We are going to have to give this a tool. Again, depending on what you guys are doing or what you're using, we should, let's go ahead, grab a smaller ball end mill from my default library. And with that, check our step downs here real quick. About a 40 thou step down. Okay, cool. And as you can see, we're starting off our part and we're running the length of the part. Now, what I'm going to show you here with contour, and this is, again, some of the nifty things of Fusion, and it's kind of why I wanted to show you steep and shallow, because it does it all in one. Again, that's a machining extension toolpath. And again, this could be worth the money for you if it's going to save you all this hassle, right? So contour is meant for your steeps. And as we saw before, Scallop does a great job in the shallow area, not so good in the steep area, right? Same with parallel. We're having issues here. It's kind of funny to see these both side by side, right? So as you see here, the shallow is the issue. Well, we could go into 3D contour and we can kind of fake it a little bit because we do have what's called a machine shallow area. And what we can do is we can actually set a minimum step down and step over, right? So once we get way down in here, I'm going to go 8 thou by 10 thou. Is you're going to notice we can start to create a lot more tool paths in those areas. But the issue is we're so flat down here at the bottom of this contour I shouldn't say contour, this bowl shape, right? This concave shape that it can't literally make another step. So what am I left to do? Well, if I really start to mess around with this and I really start to force this down further and further and further, right? So like 1 thou by 1 thou. And of course, as Fusion Fill tells you, go to 4 thou, not 4/10 for tolerance, is we may be able to get down there, but we really can't. We can't. No matter how hard we fight this, we just can't get it down there, whereas probably some of the most critical area, if I'm right. Now, this is where we can do, again, a lot of different things to try to force this. And that may be doing a combination, and I'm going to undo this because I think it's going to drive me absolutely mad. Better through, got a question there, maybe a solution that came in. I have actually gotten a better finish through the dip than running the ball mill along through the dip. Okay, so you go across the part versus along the part, if I'm understanding that. When the ball mill is climbing near the bottom, starts to cut. Yep, so completely agree. And we could look at another way to do that is on this part in particular. And Mr. Powell, you got to remind me, do you have the machining extension? In the meantime, I'm going to go ahead and show you guys kind of a neat trick. If you wanted to get your toolpath to start further off this part and run onto the part. Oh, so you do. So obviously steep and shallow is the way to go. Kick on that parallel like you saw me do. Is that something something you've tried so far? Well, you guys are going to, I'm going to show you guys, this is a trick. And this is why you need to be proficient in the design workspace of Fusion. We run a class called CAD for CAM. So it looks like that actually works out very good with the steep and shallow, but here's kind of something neat, right? You may fight getting Fusion to start off your surfaces in your part and work into them. You don't want them to make contact right as they start to cut, right? So what I'm going to do is I'm going to jump into the surface area and I'm going to go down to offset. And now what I'm going to do is I'm going to turn off chain selection and pick the couple of surfaces that I need. Now, what this does is it creates a skin, and nonetheless a skin that is a terrible looking skin on my part. And that skin now has the ability to be extended as well. So if I wanted to start off my part a little bit, you're actually seeing me create a surface to drive my machining from, which also allows me to start further out than what's happening. So if we go back to manufacture, again, we're going to use contour here. Now, this is something that I think a lot of people don't know exists or kind of overlook it inside of Fusion, is I'm going to go ahead and toggle model. And now the model surface that I want to work with is those surfaces we just created, right? Now, I can also create my boundary based on the edges of those surfaces. So what you're seeing me do here is I picked it once, I pick it again so I can extend it up and around. And now you see that green boundary is bigger. Surfaces to be machined is bigger. And when I hit OK, what you'll notice is this now starts as far out as that surface has done, and it will run up onto that part. So as he said out there, is the steep and shallow toolpath look like it would work quite well. Again, I know that it looks like Deep Thinker had a suggestion about possibly running across the part. We could do that also with our parallel toolpath, right? So if we go parallel, and again, we're going to use that same ball end mill. I'm going to go ahead and define my direction here. And we're going to say direction is this way now. One neat thing is we could actually use our origin axes for direction as well. Again, we set up our silhouette. Maybe we say selection. Let's get this out of the way here real quick. Again, I pick my loop around my part, tool on center, contact point boundary. Awesome. Everything's looking good. And now we're going to machine across that part. And we're going to do that the whole length of the part. Another thing that you guys can do with parallel, if you didn't know, is you actually have the ability to send this with perpendicular passes. So maybe you have something that needs a little bit of a different texture, or you're kind of creating like a knurling feature. I actually have that ability to kick on bi-directional basis. Now, keep in mind, right now, the primary direction is across what would be actually the z-axis in the world. But on our part, it's the y-axis, if you could see. So then it's perpendicular to that direction. So if I wanted to cross-hatch this, not based on x and y, but at 45, I would need to get an actual sketch in here that allows me to do so. So in this case, we cheat the system. As always, throw a sketch on the bottom, pull a line here somewhere, add a dimension, D for dimension, by the way. And for those of you that don't know out there, you could also set lovely shortcuts inside of this design workspace. So as you guys see, if I hit S, there's design shortcuts. Yeah, I missed lunch. I'm hungry. But also in the manufacturer workspace, you also have that ability to hit S for shortcuts. So again, we go to that parallel toolpath. My direction is now being driven from this sketched edge. And now when we look at this surface, what you're going to notice is we're getting that cross-hatching. Now, keep in mind, this is going to look a little weird because at some point we are getting vertical and everything is trying to stay in a mitered angle, right? It's trying to stay at 45. So as it gets into that steep area, it's got to go up. It can't go out. So looks good. I've tried it. I think we've also used the silhouette and selections, and it seems to do better on the containing toolpath for some reason. We're also getting a lot of spillover. Yep, so you are going to get spillover. And the reason why you would get spillover on some of this stuff is because if I say tool outside a boundary, and I don't have, say, contact point boundary turned on, or I do have it turned on, what you're going to get is what I refer to as waterfalling. Now, what's happening is it's trying to think, I need to go all the way outside of this boundary, right? I need to reach all the way to the outside of the boundary, which pushes me all the way to the outside of the part. Now, this gets really crazy, and it kind of confuses some people. When you throw on contact point boundary, notice how what's really started to happen is it's now jettisoning itself all the way out this end, right? So again, is contact point boundary works based on where that containment edge is being driven from, right? And that's an easy remedy at the end of the day where we could say tool center on boundary, and I hit OK, and now it's going to dial everything back and put me back into that position where I need to be. So let's give this a go one more time. Let's go ahead and hit this with a scallop toolpath. I would like to try based on surface groups. What we're going to do is we're actually going to add in where not to machine. Oh, looks like we grabbed the whole part there. So we're going to say do not machine this surface, this surface, this surface. And let's get spun around here. And this surface. Now, with that, if I go in and I hit OK, we should get a little bit different of an outcome. Now, it is basically the same. We're still going to run into the problem, though, I think, of, how far do we overlap? Where is the actual containment coming from? Where does the tool start its engagement? But driving this based off the surfaces still gets you something that is relatively close to be a good start for machining, right? I think with a lot of this 3D surfacing and stuff, it's not going to work necessarily on a whole part. It's more aimed at like regions of a part. But you could, again, this is the great thing with Fusion. Although they release something very powerful like this, you could still at the end of the day go in and still use a traditional containment. So we got a non-cam question. Awesome. Does Fusion have anything like frame generator for designing weldments? Currently not at this time. So that isn't an Inventor thing and it works very well. However, that is something that also you can build a configuration inside of Fusion. So you could build a custom kind of frame generator. It's just not going to be the same as something out of the box like Inventor has. Awesome, Mr. Powell. I appreciate you stopping in and being able to see the live feed and getting live support here on a Friday afternoon. If anybody else has any questions, I, again, see people coming and going. It's always great to have you guys. I'm happy to show you whatever you need, answer any questions I can about Fusion 360. Again, to any of you that were wondering, I've done live content all week. I think the live content is the way to go so you guys can see how badly I can mess up parts and then come back and see how I fixed them. But also, if you want to support this channel, as always, like, follow, comment, subscribe, share this content with other people. And if you want to do like Tony did and buy me an energy drink, or as I put, buy me a beer, because my wife can't say no to a beer, there's also a link down below for a couple of bucks here, there, and everywhere. With that, I see about 6 of you out there in chat. Anybody have anything that they're curious about? Anything they want to see? Any specific workflows? Again, this could be both design and CAM questions. I have no problem, as you can see, coming in and designing some pretty crazy parts. We'll give you guys a couple minutes to think about it. I should probably go ramble over to the old Discord, make sure nothing crazy is going on in Discord. As well, we can jump over and make sure no tickets came through. So I don't see anything coming in at this time. We're quite the bootstrapped operation over here, as you guys can imagine. And now I lost my OBS. There we go. We are back. Oh, I have a little challenge. Ball mill a cone, say a 6-inch base with a 1.5-inch flat top, running from the bottom up. All right, cool. That's a good one. All right. So we need a cone, 6 inches at the bottom, 1.5 at the top. So let's kick this off. Go ahead and create our 6-inch circle at the bottom here. And then what I'm going to do is we're going to do an offset surface to make this happen very quick. Maybe I should get some of the Too Tall Toby guys over here to talk about doing modeling, right? You guys get into that. All right, so then we want a 1.5 at the top. There we go. And then we're going to go ahead and do a loft A to B. And I'm assuming that's about what you want. Oh, 5-degree slope. I could go back and we could add 5-degree slope. That's no problem. We'll kick another model on here real quick. Let's get this model out of the way. Extrude this guy up. Oh, you want a 5-degree slope up the face. All right, I got what you're saying. Okay, so this cone should be suffice for that then. So we're going to go back to manufacture. Again, pretty straightforward setup. I'm actually going to just say my stock is my part. Makes it a little easier for you guys to see the toolpath at the end of the day. So what I would go for on something like that is going to be a 3D toolpath. Now, a lot of people forget that you do have the ramp toolpath that could actually accomplish what you're going for here. So again, you have your silhouette, you have your selection boundaries, tool containment, as we've talked about a bunch. And lastly, in the backside of this is you actually have what's called a step down and an order bottom up. So now I can't necessarily debase this off a 5-degree, but I could kind of give it a pitch, if that makes sense. So if I wanted to go up 40 thou at a time from the bottom, again, we're going to go ahead and hit OK. I'm going to need a tool here. And as if you guys can always guess, we're going to go back to our basic shop crib, grab something that might work. And as you're going to see now, this is going to wrap from the bottom up, and it is going to spiral as it goes up that surface, right? So as you can see, I'm going to come in and I'm going to ramp upwards. So the ramp toolpath works the same as 3D. But I'm going to show you another way because it just occurred to me, and I always forget about this way. We could also approach this part. Actually, no, I don't think we're going to be able to. Maybe we will, maybe we won't. With a bore, and now a bore will work based off that surface. However, you can't actually order it from the bottom up if I'm thinking right off the top of my head. So let's see if we can, I know we can reverse direction. We also have an angle. So let's see here. For direction, we want climb, yep, and ramp angle. However, we can't order bottom up here. The other one would be is you could actually do circular, but that's not going to give you a ramp. So I think Deep Thicker, at the end of the day, it looks like for what you're really trying to do, this ramp toolpath is going to be what you need to come starting at the bottom, ignore the collisions here, and then work your way to the top, right? As you're seeing as we're ramping up, my computer might explode from live streaming while doing everything else. Blend might work also, but I think blend is going to work with a consistent step down. We could go ahead and throw it at that. Good suggestion, Travis. So let's go 3D and let's check out a blend toolpath. And actually that, oh man, he might have started a fire here. All right. So what we're going to go for is we need our drive surface and we need our drive curves, top and bottom. Our passes are going to be based on a spiral. However, it looks like there's not really going to be a bottom-up ordering. So, Travis, that was close. It was close for sure. We're still going to give this a chance, and we're going to see what happens. stem head for the oil field. If I had code the program with 0.2 step, auto calculating Z to match the step. Hey, Deep Thinker, if you can shoot me an email real quick with like a cell phone photo or a napkin sketch, I'm happy to go in and see what I can do to recreate that. So again, let's go ahead and change this from 4/10 to 4/1000 so we can calculate this quite. Reverse it. All right, we'll reverse it. Give it a minute. Let's get a path on our part, and then we'll go back and we'll hit it with the old reverse. I have a feeling, good old Fusion. We're going to give her some selected boundaries just to make life easy. Center, contact point boundary, as you guys know that I love. And did it not take, oh, it didn't take, oh, it did take the drive curves. Never mind. Here we go. Let's see what we get. The other one I was thinking is steep and shallow actually has an advantage to it where it will work like ramp, where we can actually give it steep passes only, and then we can do a spiral format, but I still don't know if it's going to allow us to bottom up cut that surface. So, all right, so we got our path now. We're starting at the top and going to the bottom as Travis suggested. Let's go ahead and hit this with a reverse and see what we get. Travis might have just taught me something new, and I might owe him a beard now. In the meantime, it looks like we got a whopping peak viewership of 8 people in here right now. Anybody have any questions as we're playing around and playing Stump the Chump apparently now? If you have any questions, feel free to throw them in the chat. Oh, look what we have here. There you go. Travis might have you. Bottom up is a better finish. I've heard that a lot, and I've seen that a lot, especially with mold making. Sometimes bottom up is the better approach. But as Travis has pointed out there, is you could use a blend strategy, and that blend strategy does allow you to reverse your order of step over, which means it will actually force a bottom up. So as you guys are seeing here, again, not a perfect toolpath to start with, but the idea is sometimes it's more about getting the path on the part, because that is more important at first than trying to guess what it does and doesn't want. So again, as here we are working bottom up, as we can see, we're getting up here. Now we're spiraling around. So yeah, I mean, to me, that looks quite phenomenally correct. So either blend or ramp, like I suggested, would work quite well. Awesome, guys. Any other questions? Anything else that you guys want to see? I'm here. This is much busier than I thought it was going to be. I was going to sit here and read a book, I think. Give you guys a couple minutes to think up some fun stuff or certain things that you guys want to see. We've been streaming for a whopping hour and 48 minutes. Oh, 38 minutes. Well, look at that. Dyslexia at its finest. Go ahead and scrub the old Discord channel. We are up to a whopping 4 people in Discord. Let's go. Hey, we've already doubled our output of Discord. I don't see any tickets come in on our ticket system. Again, if you guys are looking to actually send anything in, you guys want to see anything in particular, feel free to use the email down below, the support email, join the Discord channel, anything that it is. You can even go to my actual website and submit a ticket as well. We'll give this a few more minutes. I'm going to have to start calling this the Travis Show, I think. He's got all the answers, not me. Multi-axis contour demo. How did I know? I always know that question gets asked. So, oh man. Multi-axis contour. All right, we'll do something with a multi-axis contour. I got to think about what's going to work well, but what is the best use case, if that makes sense. Oh, hey, there we go. We got Matt in Australia. Awesome. We just got home from the night shift. Let's go. Night shift where you have half the people and do double the work. That's what it always feels like. All right, so we'll start with Ken's, and then we'll jump over to Travis, which is asking about a morph toolpath. I think what we could do is we can manipulate this lovely, lovely part that I have drawn here. And what I'm going to do is we're going to throw a circle, and then let's do kind of a weirder shape. Now, all of you are probably thinking I'm crazy out here, but we'll get this fixed here in a second. I am going to split face. Shout out to to Wayne at Offset. That's me. Wayne at Autodesk. Me and him worked together several years ago, and to say the least, he showed me this trick about being able to do things with split face, where we can actually use those sketches underlying. Now, you can only do one sketch at a time, and we're going to repeat that one more time. There's our part. We want to split this face using this lovely sketch that has disappeared like always. And the reason why I'm doing this, just so you guys know, is I need to generate some hard edges to use for the multi-axis contour as I'm thinking in my head. Also, Travis, I see you out there. If you have a part in particular you would like me to show it on, feel free to send it my way. But I do have a couple of things I can come up with in my head that'll work. So, all right, multi-axis contour. So we're going to switch back to manufacture. We already got our lovely setup, XYZ. Bore you guys to death with that. But let's go in and let's use multi-axis contour. What is multi-axis contour? Well, to say the least, it kind of just comes down to being trace multi-axis, right? So what it wants is a curve to machine. So here's our curve to be machined. Again, in our multi-axis tab, we could actually set how much do we want to lean and tilt that tool. Our heights tab, again, as always, it's going to go to that edge. This is why I tell people it's very similar to trace, except trace is 3D. This is 5-axis, right? Tool set on center. Anytime we want to trim if it's impossible for multi-axis cutting. But as you're going to see is this ball end mill is now tilted to the side. And it's basically, I can't say it much more than that. It's trace, but it's multi-axis, right? So if we go in and we actually simulate this, as you'll see that tool comes in and it's following that surface, again, wrapping around that cone. So a good use case for this is if you had to do maybe some engraving on something, you're doing like a pattern. You guys kind of saw me do that hash mark thing as if it was knurling. It would be very much the same or very usable in situations like this. Now, in my opinion, this is where Autodesk could probably make a small improvement to this, is if they allowed you to do, instead of full 5-axis, 4-axis, right? Live 4th axis. I could see a lot of value in this inside of like a lathe, doing, your engravings on your lathe parts, your turning parts. We go back to trace. Obviously, trace has tool orientation, which means it's still 3-axis, right? So if I did the same part based on multi-axis tilting, and what you're going to see is I'm going to very generically tilt my Z-axis here. Again, I use my curve selection, same tool. The difference is when I simulate this, what you're going to see is we stay at that fixed angle, and we're basically going to gouge this part because, again, the whole time that tool is pointed at our part, we're not actually tilting to get away from the radius that's engaging in that part, right? So again, is if we were to do that same contour on this surface with our multi-axis, or if I switch, right? Let's switch from that chain over to this chain, and we could actually do both chains at the same time. We're now going to hold that tool. Again, you can lean and tilt this tool as much as you want, but the idea is it's basically going to sit perpendicular to that sketched edge your first time round. So again, as you can see, we're following that lovely sketch. If you wanted to lower that sketch into your part to cut this profile, if you wanted to attempt a ball end mill and deburr a intersecting hole, this could help you out as well. So jumping over to Travis's question, Ken, I hope that kind of helps you out a little bit with the multi-axis contour. I am now realizing that, okay, I just wanted to verify that I wasn't misplacing the terminology. Yes, that is the multi-axis contour. As you're seeing, is the ability to go in and basically trace tool path, right? You can add more to this by any means. You could always set, your offsets, your pass overlaps, things like that, but it still comes back to the same as maybe a couple of passes, but it's never really going to be like you're thinking contouring with 5-axis, right? As a matter of fact, Autodesk, if you're watching this for some reason, maybe we relabel this multi-axis trace, right? Can we merge this tool path and the trace together and get it all down into one? Because that's kind of how it works. Now, I know somebody out there is going to tell me it doesn't work anywhere the same. I get it, right? 100%. Chevy or GMC, they're not the same vehicle. We get it. But jumping over to that trace, or not trace, but the morph tool path, as Travis is asking, I always like looking at the actual way it's recommended to use it long before we actually draw this part. So let's go ahead and get to our morph. So it's a strategy of shallow areas between a selected contour with a constant cutting direction. What's very similar to this toolpath, as funny as it is actually the same way that like parallel kind of works. Or what's the other one is you have morph, and then I'm trying to think off the top of my head and I can't. Is there's another toolpath that works almost identical. It's guided between two curves, right? And to show this, we can again jump back to design. I'm going to pull out a new file here. Those of you that have just joined us, feel free to hit a like, follow, and subscribe as well. If you have any questions, as you can see inside of the chat, feel free to throw those questions in there. Problems. We did a little post stuff already. We've looked at, mill term. We looked at milling. Anything you guys want to see, let me know. So I now have to completely wing the idea of how I'm going to draw this feature. There we go. I know how we're going to do it. We'll do a little bit of a S curve, right? And then we're going to do another one. Well, this is going to get ugly quick. We're going to take a little bit of manipulating to get this to where it wants. I want to get this just a little closer so it kind of fans out. We'll go ahead and close this guy in. For the record, this is not how you should model. Don't quote me on this. I'm trying to put something together real quick here. All right. And we're going to extrude that out. And we're going to go back and we're going to kick that on. And we'll start with a valley, right? Obviously, it was thinking valley a little different than me. But, all right. So, going back to the manufacturer side, yours truly doesn't believe in ever drawing a part in the right orientation. So, let's get our Z-axis set. And now let's go look at that actual morph toolpath. So, I can't preach this enough to everybody. If you have no idea what you're doing, or if you know what you're doing, what do? We just hit OK, right? And then Fusion yells at you about any problems you might have. So what it's asking me for is a tool. Let's go ahead and give this a tool and find out that perspectively in my brain, I drew this way too small. Again, we're getting another error, which is you've not selected any curves, right? I drew this absolutely massive. So we're going to ramp that up to a 2-inch cutter real quick. Again, we go back to my shop crib. We could use default tools. It's not a big deal. But what it's asking us for is a curve to guide our toolpath, right? Get that sketch out of the way. So I'm going to go ahead and give these two curves to guide that toolpath with, right? Now, I'm doing this as an open pocket on purpose. And what you're seeing happen is we are more or less doing a parallel, but we're doing a guided parallel, right? This toolpath is driven by the idea that based on a morph mode, right, we have a step over. So again, is now when we start to think about it, it's almost kind of like a flat or almost similar to a horizontal toolpath, where as you're seeing is it's still thinking 3D, but it's also still thinking how to guide along its way to do something. So if we were to adjust this, right, and again, we're now machining the top. So let's give this a try with the fancy new avoidance tool. And recalculate. We're still touching that top. Now, what I might have to do again here is we may have to come in and say, you know what, I need to also add these walls in for avoidance. Or I could give it more of a traditional boundary. Again, we're getting a little bit on the ends, so we could add more faces once again for that avoidance. And we're slowly getting that toolpath angled back down. Adjust your top height to negative. Yeah, that would. I wasn't going to put that in there yet, Travis. Calm down, buddy. No, I 100%. Agreed. That is a great way to go about it. Travis is 100% right. If you have something like this where the toolpath is up on top of your part, you can 100% go to your heights tab, and you can see where we have highest of selection is stock top. Could actually say model top and then drop that by say 30 thou. And as you're seeing is it's still making contact up there because the stock is above the model. And there's a reason I did that on purpose is because I wanted to show you guys that when you go back in here, we need to uncheck stock. And now that it's based on model minus 30, right? So as you can see is what it's basically doing is it's doing a step over based on a distance, but it's following said curve. So it's kind of fanning, right? So if we go back to our design here, And I'm going to go ahead and modify my sketch. And what I'm going to do is I'm going to pull this in even further. If I can grab a point here, let's just go ahead and pull this one out. And I'm pretty sure we're constrained here because why not? That's how the world works, right? Whenever I need to do something, I somehow end up over constrained, probably like most of you. So again, we've now modified our drawing. We go back to manufacture, I regenerate. And as you're seeing, we're starting out very, very wide here. And then we're getting down in here and we're narrowing in where it's fanning that toolpath in and out. Hold on real quick. Travis kept blasting stuff in the chat. Oh, yep, 100%. So as you've seen, so he's saying is if you delete on one of the sides and have it open, it'll be just flat or horizontal. I read that right? Maybe my brain's not working, right? So as he's saying is if we get rid of one of the sides here, what I'm going to do is I'm going to do this the right way. Let's go ahead and remove this side here. We open back up. We now have a three-sided open kind of profile. We no longer are actually going to use that first guide curve. So you see me removing that. And what we're getting is an error. So no path to link, empty toolpath. And that could be because it needs two guide curves. So let's go ahead and give this another guide curve and see what we get. And again, now what's happening is because it's trying to stay between the two curves, the curves we're defining for saying where that toolpath needs to go. Travis, does that kind of answer your question? In the meantime, it looks like we're up to 9. Wow, we've actually peaked out 9 viewers at once, guys. We are record high. That said, any of you guys out there that have any questions or any curiosities or want to see anything inside of Fusion, anything you've wondered, feel free to go ahead and ask. Yeah, it is a different and interesting toolpath. You're right. I'll be honest with you, and a lot of people will probably hate me for this, is a lot of these toolpaths, once in forever does it tend to come in, right? Like a lot of these toolpaths were really good as they started to be in Fusion or they came into Fusion, but nowadays when you get into flow, the morph, again, getting more into like blend, it's one of those things that I don't find myself using a lot of them as much as I used to. There we go. We're up to 10. I don't know what is going on. Did somebody share this with their family and they all joined in to see what's going on? But, oh, we got another one from Travis. All right, what do you got? If you had to put a hole in a cylinder at a specific degree, how would you model it and make a spiral of the hole going around the pipe? Ooh, that is a tricky one. All right, let me read through that one more time. My brain's trying to wrap my head around this this pipe. All right. So you had to put a hole in a cylinder at a specific degree. How would you model it? Like a spiral of holes going, oh, okay. Spiral of, oh, all right. So you're kind of like holes like around an end mill, right? Like fluting with holes. I see where you're going with this. Okay. So modeling it, total pain, as always, but what we can do is trying to think. It's been a minute since I've had to do this, but it's going to be a little tricky, right? Looks like Ken came in. Make a sketch and use pattern drill on the sketch. I think I have an idea of what Travis wants, and why did I know somebody was going to ask this today? So what he's saying is, let's say, for example, you have a 2-inch piece of pipe. And then with that, you're going to have kind of like a 12 o'clock position. And then I'm trying to think what's the best way to go about this. So we're going to add a few more here. All of you are going to see the magic happen today. That's for sure. Okay. And then we are going to offset. If anybody has a suggestion on a better way to do this, please let me know so that I can stop making a fool of myself. All right, there we go. Now we're going to create a sketch here. We are going to project this guy. And then we are going to make another sketch here. I'm curious if this is going to work too. So if anybody just joined us and they're wondering what I'm doing, I'm partially losing my mind. No, that's not true. We are trying to recreate what Travis is talking about, and we want to project. That's right. Project. And we're going to project this point. Okay. So what has kind of happened here, and it's going to be a little tricky to see until we sketch this out, is I have actually created kind of 3 reference points in space, and then I am going to do a fit point spline. Problem being is I can't grab my original point, so let's back this up real quick. Go back to my original sketch. Point. Oh, nope, that wasn't my original sketch. Look at me lying to you guys. There we go. We got to go with this one. There we go. Do a point here. Okay, so what I've now created is basically a spiral up my part that I'm hoping to use for a fit point spline. All right, we got to turn on 3D sketch here real quick. And now we should be able to grab those points in space. And as you guys can see, this is kind of the whole pattern that's going to wrap up and around my part, right? So again, as we're going to create a sketch here now, hopefully I can cut this cylinder as we've talked about. We'll go a little past that. And actually, I'm going to say 2-sided here. And we're going to extrude our hole now. And let's just say this goes through all. And now if this is a strong if, right? Pattern on path. I don't know if it's going to do it. Pattern a feature along this path. The thing is it's going to, yeah, see, it's not going to wrap itself towards the center. So another way you could kind of do this, and it may be cheating. So you do have a model, that's great. Send me a model, but I think somebody else out there would probably be curious about this as well, is I could take that actual face and I can copy and paste those and move those actual features as well, if this was something you were looking to do. So again, there's a lot of different ways to do something like this. You could, as you guys saw before, we could do a offset face. Now I could take said face, if I could find it, and we could do a move command based on, I'm going to set my pivot dead center, and then I can move that up and I could rotate it, whatever he was talking about, right? So roughly there is up and out 30 degrees. And then from there, I could then cut my body based on where that cylinder is, and then rinse and repeat and pattern as set. So it looks like Travis set that part over. All of you guys in chat, I appreciate all your time. I appreciate you guys coming to check out this channel and see how I have no idea what I'm doing in live streaming. Outside of that, we have a, oh, all right, here we go. Let me get this pulled up here. And going to take me a couple of minutes, so if you guys want to go grab a beer, sit down, relax. In Ken's case, I think he's got to change a part out. He's been here for 3 hours, right? Need to fix my, there we go. Get this downloaded. And let's go ahead and pop open our lovely workspace. And let's clean up our workspace while that gets uploaded. I need to also check the tickets, check Discord. You guys don't know, we actually have a Discord channel now. There's a link down in the bio. You guys are welcome to join. You're welcome to bring in anything else. And here we go. Let's get that cleared out. No longer need this part for Mr. Powell earlier. All righty. So, ported pup joint. Let's see what we got going on here. Oh, all right. Cool. Pretty easy. So now you're talking about wanting to pattern your holes around this part, or what do you want me to do? So let me go back in the chat and see what Travis was asking about. Oh, look at how you had to sketch it. All right, let's pop open the sketch. So what I'm seeing is it looks like you projected. All right, so you created planes at angles, and then you created a sketch, and then you, yeah, I see what you did. And then you extruded that into your part, right? Completely doable that way. There's no right or wrong way to do something like this by any means. And then it looks like once you created one loop, you basically had what you needed. I kind of started to do this, and of course I deleted it. But from that is you could have created, you know, same way as right out of center at angles by any means. And I mean, there's no, to say the least, you kind of did it about as good as you're going to get it. And then you presumably just patterned it down your part, right? There's not really an easier way because the pattern along path doesn't really account for like twisting down a part like this. Now, if anybody else out there does know of a better way, feel free to throw that in the chat and let me know. But one neat thing, again, is if we were to manufacture something like this, which I assume Travis had to do at some point, right? Is now I could go through in the traditional way of Fusion. We could set up, you know, our XYZ. Travis is like me, doesn't draw in the right orientation. Let's put this on center. Let's get our data panel closed here. And then if you would have traditionally done this in Fusion, a lot of you would have went in and you would have said drill, and then you would have gave this a drill. Let's see what I got in my shop crib for drills. We'll just use the spot drill, right? And then you could have did your tool orientation. The problem is once you select your first hole, and then we say select same size hole, we're getting into problems of crossing over to the bottom of our part. I also see something pop into Discord. All right, we got another person in Discord. That's awesome. Now, as you're seeing, is it's patterning both sides. So we could say only same Z top, and then that would have limited us to the top row only. But then we would have had to rinse and repeat here, right? So then either I need to figure out a pattern, or I need to, in this case, duplicate this tool path, and then go in, say tool orientation, pick my new Z, pick my new whole face, and then away you go, right? So again, as we need to flip Z here, and then from there, my geometry is now this hole. And now you can see that pattern has now shot down my part once again, but I would have had to rinse and repeat that, say 6 or 7 times, right? I would agree with you. The way you modeled this is probably the best way, but the fact that you beat your head against the wall and probably had no videos to show you how was probably the real pain, right? But as you guys are seeing, again, is just rinse and repeat of having to pattern this around. Now, for those of you with the manufacturing extension, you could actually cheat this because what you have is hole rec, which would allow me to go out and find all of my holes based on multi-axis, right? So as you're seeing now, is it's automatically finding each hole at each orientation to include the giant hole at the end that I would actually tell this to ignore. So as you can see, all 6 rows of holes are being picked up in real time, and then I can pull my tools from my own tool library to auto-generate all those tool paths. So within a matter of minutes, which Travis might be kicking himself unless he did use the machining extension, is there is now my ability to create all my tool orientations and all my drilling procedures with spot drills and actual drills within a couple of mouse clicks. Yo, you got it now? That's good, man. Sucks for back when, though, right? Now, I believe, don't quote me on this, guys, but I think there is a new feature to Fusion that would allow you to create a hole template with your holes at angles. I may be mistaken. So again, let's just go ahead and see what we can do with this. We don't want the end of the part. Again, we want to go ahead and pull one of these holes at an angle, and then we want to select that whole face. Let's say we do select same size and only same Z top, right? If we turn this into a template, store as a template, and we're just going to call it drill, sure, because we're going to pull it back later. I'm curious if we go in, create from template drill. Yep, So it isn't going to, we would still have to define our multi-axis angle as well as our whole face. So it looks like you can't really cheat the system as much as you would like to automatically go find those areas. Great to see all you guys in here. If anybody has any questions, feel free to throw them up in the chat. We're just hanging out, anything at all. If you have questions, problems you've previously encountered, want a different thought process on how to do something, feel free to send it over. I will say for the 8 of you that are in here, I will be taking probably another 5-minute break here because I need to run to the bathroom. But looks like Deep Thinker says, oh, did I mute myself? I did not. Those holes are actually counter bores, not through holes. Nope. So you are correct. Those are counter bores. They're not through holes. And that might actually just be the way that this was designed, that some of them have bottoms to them. You're going to have to add, oh, nope, it's me clicking the surface all the way through the part. That's on me, Deep Thinker. But I'm going to take a 5-minute break. Again, for any of you that have just joined or any of you that have been here, if you guys have any questions about Fusion, anything at all, any of your needs, whether it be minor post-processor edits, how can you do this? How can you do that? How can we improve on things? Let me know in the chat. You could also join our Discord channel and message me there. And I will be right back here in 5 minutes. All right, guys, and we are back. Once again, oh, looks like my camera got bumped around a little bit. Let's get scooted in here so you guys can see this big, beautiful face, of course. So it looks like we did get a question in, and anybody new here, feel free to pop a question in anytime you want. That being said, it looks like we have Brett out there, and Brett is curious about his UMC 750, and he would like the spindle to retract above the Z home after every tool change. So one thing that I actually got a question like this earlier today. I completely spaced off on this, but I have a really interesting way to show you how to put this into Fusion. Yeah, and 100%, Travis has got it right, is you could put in a home position inside of your machine configuration to be able to manually set that. Now, this is a great question. I'm going to show you guys this because you could actually change where your table goes and everything when you post your G code at the end of your program. So, Brett, I just want you to let you know on your Haas machine too, there is a setting that you could set that in the controller. But for the rest of you, let's go ahead and pop open a part and take a look at something that we can use in order to set that up with our machine simulation. So I'm going to go with the good old-fashioned dummy part here. And what we're going to do is we need a machine in order to do this. So I'm also going to turn off the sketch that's going to drive me crazy. Let's go out and select our machine. It looks like he had a UMC 750. I'm trying to see if I have one in my default library. I'm not really a big fan of having to download one unless I have to, but it looks like we will because I did just recently reformat my machine. So let's go find one. Oh, not Autodesk. We want Haas, and we want a UMC 750. That's the reboot. Download the good old model. This is a good lesson for you guys. When you have to download this model, I highly recommend you put it somewhere where you know where it is because you're going to need it from time to time in the future. I actually throw all mine in a machine model folder so that I can pull them at any time and I can keep them and update them. So as you're seeing here, is that machine is going to download. This is going to take a couple of seconds. And with that, we now have our machine. We also have our part. I am going to run through this real quick and show you guys where it is, but I want to just put my part on here. Now, if you're like me, and this whole enclosure drives me absolutely crazy when I have it my way, when I simulate with machine, give this a second here, is what's going to happen is that machine always seems to be in the way. And until you turn off the base, you don't know what's going on. Also, first time that you simulate anything, you want to make sure that you go based off the machining base for your simulation. And as you can see, we're causing a lot of collisions right now. It's not the biggest deal, but it really does kind of drive me crazy when I'm trying to put my part in the machine and figure out where stuff's going, that this machine just comes in such a weird direction. You guys have the ability to edit that and be able to fix it. And how you can do so is we're going to actually edit the Haas UMC 750 that I have here. So we're going to give that a second too. It's going to take a moment. Keep in mind, guys, I am live streaming this on the same computer that I'm doing everything on. Now, we cannot edit the machine that's linked right now. I'll show you another way to go in and edit that machine. But one of the questions that I saw was Brett asked about how do I set the home position in Z 3.2 inches up, right? So how you can do this is you can actually go to the Z axis, and then in your Z axis, you have that ability to say the home position is 3.2, and you can also set the maximum travel, because this is in a positive direction, to 3.2 here as well. So what's going to happen is when you call your G53, it's going to plug in this actual number. So if we go back to what we're doing here on this part, I'm going to post this out. And we're going to go ahead and open that up. And it's going to make me a liar because I probably crashed the machine, and it did not. So if you guys are watching this earlier in this video, we hand edit this G code, but by using machine definition, as Brett was asking and Travis pointed out, is we can edit the actual home position on our machine to wherever we want it to be positioned. So as you're seeing is we went ahead and put it 3.2 inches in Z in our G53 callout line. Now, you could do more than that. Is if we go back in and we post-process, let me go ahead and check something, because I think we do have the XY on indexing. You do have the home position center setting as well, as some of you may know. But a lot of my customers are actually getting fond of putting a table on center. Again, if you go to that y-axis or that x-axis, you could actually bring your table up in center every single time of that door. So now let's look at going in and editing our actual machine, right? So what I'm going to do is I'm going to pop open a blank file. Again, we're going to switch to the manufacturer workspace, and then I'm going to go to my machine library. Now, in my library, I should have my UMC 750 somewhere, and here it is. I now can right-click and edit. Now, you could have just went straight to Edit Machine Builder. However, I'm going to go down here and I'm going to click Machine Builder. What this is going to do is this is going to pop this machine out into a separate tab, and this is where I have the ability to change whatever I need inside of this file. So, for example, here is we have a setup machine model. There is a static part, which that static part is including everything under the static section, right? Well, maybe I don't want all of that in there, right? So I am going to walk through this and basically turn off kind of anything that I don't want. Now, I'm not going to do all of this. I'm not going to spend a ton of time on this. Just whittle everything down to the absolute minimums. But as you can see, you could actually come in here and dismantle basically this entire machine down to the bare minimum that you want, right? So again, let's go back up to the top. So that's the outer enclosure. Again, you can manipulate and modify this to whatever you need to get all of that stuff out of your way, and then possibly go back and redefine strictly whatever that enclosure piece is, or maybe it's the machine base itself, right? I'm trying to see if I can see it here somewhere real quick, or if it's hiding somewhere else. But as you see, let's go ahead and kick on static. We'll leave that saddle on back there. That actually kind of makes sense, right? So there's my static piece as I've picked. Again, because we've turned everything off, you now have that to your advantage when you go in and do your machine sim, right? So again, we'll let that load out. We'll hit close here. I go back to my part file, wherever it lies. Again, we now bring in the latest and greatest machine. The same method works as you guys saw me do before, is I'm able to put joint origins in a lot of different places on my machine, right? I know somebody was asking about mounting a vise on the right side of my platter. I could put joint origins to make my life much easier for my jigs and fixtures. But now when we look at our setup, or if I go to a new setup and I grab that machine, right? I don't have the entire machine in my way to be able to set up and run my machine sim. Now, me personally, I don't need the pendant and the enclosure and the chip conveyor up here for me to place a part, right? I'm not going to hit any of that stuff. Now, if you're going to work with a part bigger than your machine that's outside your travel limits, sure, maybe leave it on, right? But as you can see, this makes it much easier for me to go in and set everything up. And in this case, I don't have any fixture attached to this part. So let's go ahead and throw on some jigs and fixtures. And let's expand that out, because I do know inside of that fixture, I think there is a stock model. There definitely is a stock model hiding in here. So again, we grab everything but that stock. There's my jig, there's my fixture, there's my tool path, and away we go. So hopefully that actually answers your question, Britt. If you have any other questions, feel free to throw those up in the chat. Again, anybody new jumping in to see this, as you guys see, I'm here to answer any questions you might have, any problems, any solutions to those problems, any way I can help you guys to be more proficient with Fusion. I'm also going to hit you guys with the old 30% off. Again, I love the fact that Autodesk has found a sense of humor in making these memes about the discounts. Keep in mind, we are also at jitcadcam offering 30% off of our services in any way that we can to help you guys become more proficient, find better workflows inside of Fusion. All that goes towards us being able to develop free content like this for you guys to consume, and helps anybody and everybody in the community to get better. Now, if you are in a position that you don't necessarily need support and you still want to support the channel, you do have the ability to go out and buy me a beer with the link down below. So you said this works, but not with the tool changes. I would have to, let's take a look at it. So we did modify this. Let's throw another tool path at this guy real quick. So we're going to face this and grab a different tool. And we're going to put this up here with the other tool path. Give it a sec. It's recalculating. We'll get that posted out. Again, any questions whatsoever, feel free to ask them. I'm here to help in any way I can. And at a worst case scenario, I'll have to get back to you at a later date about something. So give this a few more seconds. Let's post out this entire setup. And okay, so we start out at 3.2. Again, we're at 3.2 here at the end of the program. We do our tool change, so we should actually come down. So I see what you're saying. So what you're saying is right here on this line, we actually need to include the Z retract. Easy thing to add to our post, right? So what I'm going to do here is I'm going to go ahead and post out this G code. And what I'm going to do now is I need to edit that post processor. So as you're going to see is this post processor came with the machine. I cannot edit it. So I'm actually going to go to a different post, and it's one that I've butchered pretty good here. So I'm going to grab just another Haas post, but this is going to be pretty identical. Again, you guys saw me do this earlier. Make sure you have the Autodesk Post Utility plugin on Visual Studio Code. We go in, we generate some generic G code. And as you can see here, we go ahead and do our first retract, and then we actually have our Z0 position here. We could develop a pass-through, or you could do an action if you wanted to add all the extra to it. But really what I'm looking for is basically you have right retract Z, but up here we also have, oh, this is the one that I manually edited, right? So cool thing. Glad this actually happened. Now, we're trying to use the debugger, and the debugger is not working to give me the G code to actually understand what I need to do. Well, there's a secret to this. Now, what I'm going to do is I'm actually going to turn off the machine configuration, right? Is we're going to go back and we're going to post out both toolpaths. With that, we turn off machine config, and we actually have a post from Autodesk in the default library called export CNC file to Visual Studio Code. What this is going to do is this is actually going to dump everything that you just saw in this toolpath, and it's going to dump it out so that we can pull the exact thing inside of Visual Studio Code. So again, as I'm going to go back up here to the top, we're going to hit post process. Again, I'm going to have to swap out my post processor. We're going to edit that. And then if I come over here to the right and expand things out once again, you will have a section under CNC called custom. What that custom is going to do is it's going to dump out the exact G code that you need. Now, this one is giving me a error, which means this post processor has been tampered with earlier in this video and caused me some problems. So let's go do this the right way, which is going to be Fusion Library, Milling, Haas, and we are going to grab the next gen control, copy it over, paste it, and now let's edit it. Again, we're going to go in and we're going to use that custom 1001, and we are going to get another direction is not supported for machine configuration, which we may have to turn on some accesses real quick. So we go to machine selector. Actually, not machine selector. We need, where is it here? Post properties. And then what we're looking for is we can either do the manual has A, has C, or we could go to machine model. And if I click this, it'll pop up here on the top. So by plugging in the 750, we've now dumped a new debug file. And then in metric, so keep in mind, guys, this is in metric by default. Here's the line that does the right retract. So I'm going to go ahead and copy this. And then I'm going to go down to wherever that G53 line is here, right? So we're going to set our ABC plane. Now I can plug in front of that ABC plane, I can set that actual G53 callout or the right retract as you're seeing, right? So based on how you're going to do this, again, I'm not going to show you. I'm going to leave this alone at the moment and leave a little bit of mystery, but you do have that ability to reach out to me so that I could show you how to plug this in or how to make that change on my end. But as you're seeing, you have that ability to do a lot of things inside of Fusion and paste things in and hit save and see whether or not you get what you want or if you crash the post. And again, this is why you copy it over. I put mine all in my local folder until they're proven. Then I move them to the cloud. Any other questions outside of that while we're still going? So we got a few minutes left. I think I'm going to shut this down a little bit early because I was not anticipating this much talking. Go ahead and give it a few more minutes. Does anybody out there that's currently in the live view area or the chat have any more questions that they have? Any more curiosities? Brett, feel free to shoot me an email with the support down below in the info of this actual video. You can put in a ticket, it'll auto create a ticket, and I'm happy to make those changes for you offline. Again, any other questions out there? Anybody at all? Going once, going twice? We'll give this about 4 more minutes before I go ahead and start my Friday. Awesome. No problem, Ken. Thanks for coming out. I think I'm going to do another one of these next Friday. I might limit it to 2 hours versus 3, but I appreciate it. So as Dylan is asking, Dylan, yeah, I mean, my plan at this point is I think I'm going to do this every Friday until either my wife tells me I'm no longer allowed to do it or I run out of stuff. But that's the whole point of this, is for all of you to bring the stuff, me just to teach the way and try to walk you through it. Awesome. Anybody else got anything that they would like to see? Any curiosities? Any problems throughout the week? Travis, I appreciate that a ton. As I always tell you guys, you know, it's not what you know, it's who you know. And that is, as you know, Fusion Phil over here live streaming how to fix problems and all kinds of stuff. So it looks like we did just get another question from Brett here at the end. This is a dumb question. No such thing as a dumb question. I've made a living off dumb questions, right? But is there a way to control a 2D adaptive without sketches? Yes. So there is actually a way to do so. This is a perfect part to do something like this on, is if I was to go in and say 2D adaptive clearing. Again, I'm still going to hit this with the tool orientation just because the nature of the part. Now, if I go to my geometry tab, instead of actually defining things based on features and edges, I can pop out and I could say I want to do something like a silhouette of that part, right? Or there's also pocket recognition. So you can actually use pocket recognition. This will give you the ability to go through and define several different actually feature-driven kind of items. And then from there, as you've seen, I've just hit OK. It's automatically recognized that this is an open pocket through my part. I did that a little quick, but I'm going to go ahead and show you that pocket recognition 1 right here saw that that was a pocket and auto established that it needs to machine that pocket, right? So again, you could go through and you can change all of this information, you know, minimum corner radius, maximum corner radius. As you're seeing by me changing nothing more than minimum corner radius, the toolpath has automatically gone in again and found all those little areas. That's right, Travis. The only dumb question is the question that doesn't get asked. Over here at jitcadcam, we believe in if I get the same question 3 times, you're not the only ones that are asking it, right? So we always love to make video content on questions. So Brett, I hope this helps. So you could set up a pocket recognition for, you know, obviously pocket clearing, but you could also set up that toolpath to work off of anything based on the silhouette of the part even. So we could go back and we could say silhouette. Now you do have an outer loop, inner loop version, as well as all loops. So again, as if I just want, based on a body, to go in and actually auto recognize everything that needs to be machined, I can do that as well. So he has a simple part in a 3-inch diameter. Okay, all right, let me start from the start. So it's a simple part in a 3-inch diameter part, and I can't seem to figure out how to control the tool to start the tool from the outside of the stock without a sketch. I see what you're asking. Okay, so what you can do in that situation is, one, don't use 2D contour. You could use instead, and this is, again, this is a perfect example, is I'm using 3D adaptive here. And with that 3D is I'm actually utilizing defined by the stock, or in this case, it's a little easier to understand, a silhouette from setup stock, right? So with 3D, it is model aware, and it's going to work from whatever you define to the actual model, right? So as you can see, I could say no boundary, silhouette from setup stock. And in this case, we actually have some avoidance happening automatically because of the jig. And if you guys haven't checked it out yet, that video that I did earlier today, the live stream at noon, goes over the all new avoidance, and I highly recommend you go check it out. But this is why we direct people towards 3D toolpaths more than 2D, is because it is model aware and it doesn't actually require defining items. So as you can see here, had you swapped out to 3D, you're going to go in and, well, a couple more questions coming in. Yeah, so Travis is more than willing to help you out. Brett, I also am more than willing to help you out any way I can, but this is why I always recommend 3D toolpaths in those situations, because they are model aware. You could set up 2D as well with stock. There is the ability to do rest machining as well and define anything and everything on your part, right? So you could say stock contours the same as I did with 3D, and this will allow you to go in again and define whatever it is that you want to use. Maybe it's silhouette, maybe it's silhouette outside, right? And then again, without picking things on my model, I've automatically roughed the outside silhouette of this part. Brett, I would tell you, go ahead and send me an email to that support ticket. I'm happy to jump on a screen share and see exactly what the issue is that you're having. And as Ken is asking, will Fusion allow you to have a single setup that uses both the side saddle and the platter? No. So one thing that is lacking, and I think they're doing something to remedy it, is you cannot do two setups in like a world of simulation. So if I had two vices side by side, setup one, setup two, it's not the best for the simulation right now to be able to jump between those two, or to even, as you may know, minimize tool change on your posting, right? Cool. Any other questions outside of that? Going once, going twice. See what time it is here real quick. Pull up my clock. All right, we are past the half-hour mark. So 2.5 hours we've been at this. I hope you guys appreciated all of it. I thank all of you that have came out and enjoyed this. Anybody that's watching this recording at a later date as well, we appreciate you very much. On top of all of that, it's not what you know, it's who you know. You guys all know Fusion Phil over here at jitcadcam. Feel free to use that support link down below to send me any information that you are requesting, anything you guys want to know. I'm here to help in any way I can. And as always, have a great rest of your weekend.